Night rests upon the poles like a slow blanket, and something begins to breathe inside it. He stands beneath a sky that looks ordinary at first, an ink-blue vault pricked with quiet stars, and feels a hush arrive from very far away. Somewhere beyond clouds and aircraft lanes, beyond the cold whisper of the tropopause and the rarefied calm of the thermosphere, a river of particles leaves the sun and wanders across space. It is not a violent river at this distance. It is a ghostly tide that has traveled the width of an unfathomable corridor, carrying fragments of a star's restless mood. When it reaches Earth, the planet answers without a sound. The sky rearranges itself into curtains that seem to be sewn out of water and fire at once, folding and unfolding with a patience that invites deep breathing. The colors do not shout. They lean forward like confidences and then retreat like fog. The motion is patient, pastoral, unhurried. It feels like a story that chose silence as its narrator. He watches a green arc emerge on the northern horizon, faint at first, a bruise of color in the dark. It arches as if testing the fabric of the night for strength, as if searching for the exact seam where earthbound sight meets spaceborne phenomena. The arc brightens and becomes a ribbon. The ribbon ripples. It makes a staircase up the sky. Above the horizon, faint stars disappear behind its soft intensity, and where it touches the zenith, the color grows deeper, an emerald ink diluted by blackness. The night is cold, and the air is still. Yet the landscape feels warmed by the sight. Snow and water and rock reflect a green that does not belong to them, and yet they accept it without complaint. The scene resembles a cathedral built of weather. He does not speak. He barely moves. The world seems to have found its pulse again. No thunder accompanies this brightness. No crackle reaches his ears. The phenomenon announces itself by subtraction, by dropping the usual clamor of thought and replacing it with a physiological calm. Pupils widen in the dark, heart beats slow. Each inhalation takes on the rhythm of those graceful folds. The mind, so skilled at amplifying the noise of errands and frustrations, softens its grip. The viewer senses a border being crossed and does not resist the passage. If awe has a resting heart rate, the aurora knows it. This gentleness is not the full story. Far beyond the visible light, there is a conversation unfolding. The sun releases a steady breath of charged particles, a wind that thickens when storms boil on its surface. These particles travel outward and meet Earth's magnetic field, a protective bubble that diverts and channels them. Along magnetic routes that curve from polar space toward polar air, electrons descend into the upper atmosphere and transfer their energy to atoms and molecules. Oxygen begins to glow at heights where aircraft never fly, around 200 kilometers up, and it yields a green line that the human eye loves to follow. Higher still, a deeper red appears and spreads like wine across a cold table. Nitrogen adds violets and blues that lick the edges of the green like frost on glass. All of that chemistry and all of that geometry compress into a gentle spectacle that looks like repose even when distant space is shaking. The arc widens. It becomes a curtain, then a valley of curtains that overlap like silk. Here and there, vertical rays form as if invisible hands were lifting the fabric. Their edges hold for minutes, then disperse into veils. Sometimes the curtains rush forward as a wave, and he feels, without a sound, that a boundary has passed over him. The air does not stir, yet a pressure changes inside the chest. Ancient storytellers might have called it a visitation. Today, it is quiet physics translated into theatre for the eye. The strange miracle is that a storm beyond weather has chosen to look like composure. Under this light, human things grow gentle. The crunch of boots sounds smaller. Conversations trail off and do not resume. Cameras click, then stop clicking, as if each device has learned the limit of what it can keep. The green grows thinner and the stars reappear through it, sparkling like distant villages seen through fog. He imagines those villages sleeping under the same sky, unaware of the benevolent turbulence that sweeps over their rooftops. The aurora rewards those who wait outside the circle of noise. It is a reward measured not in selfies or proof, but in the reorganization of attention. The attention grows long and thin, like the arcs themselves, and settles on patience. There is a paradox at work that soothes the heart. The source is wild, but the face is serene. A solar wind, born from boiling magnetic fields on a star, has traveled a gulf that numbers cannot fully humanize. It has driven currents into Earth's surrounding space that could light cities. Yet the visible consequence seems to slow time. The colors arrive in measured gradients, the forms in soft cadence. Nature dispenses its intensity in a dosage the mind can absorb. The phenomenon comforts because it demonstrates that vast systems can translate their fury into elegance once they meet the contours of a protective field. It is a lesson in mediation. It is a lesson in the usefulness of veils. He notices how the green searches the sky. It hunts along magnetic lines that his eyes cannot see. It forms a circle centered not on the geographic pole, but on a magnetic partner that does not sit still over centuries. The circle breathes, enlarging and contracting, teaching the sky the motion of tides without water. Sometimes the circle breaks into patches that drift and reform. Sometimes a surge comes from the east and the whole geometry rotates. The viewer does not need to know the equations that describe these motions to feel their order. The order is evident in repetition without sameness. Each minute offers a pattern that belongs to this minute alone. The curtain brightens. For a handful of seconds, fine structures appear inside it, as if someone had combed the hair of light. Threads line up, each thread a slender rod reaching upward. They flash, they vanish. The curtain yields to ripples that run sideways, like wind on meadow grass. The green becomes a pale aureole around a darker core, and then the core softens and the whole sheet fades. Darkness briefly owns the vault again. The eye, now adapted to luminance that never touches the ground, drinks the stars with appreciation. The sky feels larger for having contained both brightness and its absence. Then a surprise. A new arc blooms in the south, not common, not expected. It is thin and lavender and far lower, a shy whisper against the darker horizon. It stretches into a straight line that belongs to a different grammar than the northern drapes. It seems almost like a roadway drawn across the sky by a careful hand, a single stroke that does not fray. For a moment it stays still, then glides. The motion is delicate, a slow march that resembles a pause more than a journey. It does not last long, it fades to memory, and the northern curtains resume their place as if they had merely blinked. He feels the simple intelligence of the body taking notes. Breathing follows the upwards flow, then the downwards settling. Eyes track the gentle drift and discover that they do not tire. The neck does not complain. Time loses its sharp teeth. Even cold, a strict teacher, becomes an ally because the sting of air on cheeks and lungs sharpens the senses just enough to keep a quiet vigil. The Aurora does not demand frenzy. It asks for willing attendant. In return, it offers a wordless correspondence between the vast and the intimate. This is relaxing, but not trivial. It is not a scented candle for the sky. It is the visible remainder of an invisible exchange between a star and a planet, filtered through a magnetic architecture that keeps oceans from boiling and breath from wandering away. The calm seen here is a signature of safety. Living minds recognize it the way a sailor reads the sea or a farmer reads clouds. The eyes soothe because they can trust that a shield is working. The beauty is not a trick. It is a real sensation carried on real physics, the elegance of a system that has trained ferocity into grace. He waits for the final act of this particular night. The arc thins again, and the curtains retreat toward the horizon. A few narrow rays linger, like notes at the end of a hymn, held a fraction longer than expected to let the hall absorb them. Then darkness returns in full. The stars regain their crispness. The snow sighs underfoot. He realizes that his shoulders have dropped and his jaw has unclenched without permission. He looks around at the quiet land and feels that a room inside him has been tidied. The north is dark once more, but he now carries a residue of green behind his eyelids, an afterimage that will follow him into sleep. He turns away and the night follows, not as a weight but as a gentleness that has chosen to stay. The lesson is simple and vast. A storm can arrive as solace. A distance can turn into touch. A restless star can teach a human being the correct speed of a breath. The sky does not ask for understanding before it gives its comfort. It only asks that someone be there to see it, still and unhurried, while light learns how to move like peace. Long before instruments, the night itself served as archive. Hunters and herders on northern routes learned to read the cold sky as if it were a skin of stretched parchment. The lights appeared, and songs followed. In winter villages, elders described glowing rivers that murmured without sound, and children learned to keep respectful quiet while the colors moved. Along Arctic coasts, storytellers imagined spirits at play. Across the steppe, travelers spoke of distant fires that never warmed the hands. The words differed, but a pattern formed in memory. The lights gathered near the pole. They arrived in fastened seasons. They appeared more often after bitter winds and unusual sun halos, and they could turn a settlement silent by their presence alone. Ancient scholars kept their own notes. In Mediterranean cities, observers recorded crimson banners and sky fissures that unsettled the populace. A Roman naturalist listed fiery openings and sky glows alongside comets and halos, trying to fold the phenomenon into a catalogue of wonders. Centuries later, chroniclers in East Asia described pearl curtains and purple vapours that crossed constellations. In temperate Europe, the rare spread of luminosity into southern latitudes triggered sermons and petitions. A puzzle was slowly, patiently accumulating witnesses. With the birth of telescopes, a new kind of curiosity took hold. A French philosopher in the early 17th century gave the northern display a name rooted in dawn and north wind, Aurora borealis, a phrase that suggested both beauty and geography. An Italian astronomer studied the same light and argued that sunlight scattered by high vapors might be responsible. Neither naming nor early theory settled the matter, but a boundary had shifted. The glow had become a natural object to be explained, rather than an omen to be endured. A dramatic storm in the early 18th century carried the aurora down to crowded cities. Londoners watched crimson waves climb over rooftops, and the fear that gripped them drew the attention of a mathematician and astronomer who suspected magnetism. Armed with the logic of compass needles and the reach of Earth's field, he connected polar brightness with a planetary force that already guided navigation. The hypothesis was bold for its time and opened a path for measurements. The glow might not be a fire in air, it could be a sign of currents in a wider envelope around the planet. 2 Swedish observers followed with decisive evidence. In Uppsala, a careful astronomer and his colleague compared sudden sky brightness with sudden swings on magnetometers. The correlation appeared like footfalls in fresh snow, unmistakable once seen. Each time the lights flared, the needles moved. The aurora was not simply above weather, it was coupled to a moving architecture of fields and currents that circled the planet. Science had found a handle on the phenomenon. Photography entered the story and made heights measurable. A Norwegian mathematician and physicist used paired cameras and triangulation to calculate the altitude of arcs and rays. The numbers surprised even seasoned observers. The glowing forms hovered far above clouds, far above the paths of balloons, in a realm where air thins into plasma. Heights near 100 kilometers for discrete arcs and higher for faint red veils stripped away ideas of combustion or earthly vapor. The aurora lived in a cold, rarefied ceiling where collisions are few and energy travels along magnetic pathways like melody along a string. A restless Norwegian experimentalist decided to build a sky in a laboratory. He placed a magnet inside a vacuum chamber, released electrons, and watched luminous rings gather around the poles of his little metal Earth. The device had limitations, yet the pattern was unmistakable. Charged particles guided by magnetic fields produced arcs and ovals that resembled the living sky. He backed the experiment with expeditions into the Arctic night, setting up observing stations under stubborn weather, and returned with logs that sang the same tune as his glass chamber. His proposal of currents flowing along magnetic field lines, invisible ropes connecting space to atmosphere, was greeted both with admiration and doubt. It would take decades and new instruments to settle the question. The mid-20th century delivered those instruments. Rockets pierced the cold ceiling and carried cameras and particle detectors into regions that had previously been only geometry. All sky cameras multiplied across northern communities, each lens swallowing the dome of night and printing the shapes of arcs like fingerprints. A year dedicated to global geophysics created a network of magnetometers that listened to the planet around the clock. The data drew an oval around each pole, a luminous belt that expanded and contracted with the sun's temper. The aurora was not a random stain on darkness. It was a structured region, the visible edge of a planetary engine. Satellites then wired the story together. Early spacecraft sampled electrons streaming toward the atmosphere and found beams aligned with magnetic field lines. They recorded electric fields that would accelerate particles and magnetic disturbances that hinted at wider rearrangements in the magnetosphere. Measurements from high above matched dances seen from below. A theoretical framework took shape to explain how energy from the solar wind could be loaded into Earth's magnetic tail and later released. At each release, the oval surged, arcs multiplied, and magnetometers ticked. Hidden currents were receiving confirmation, segment by segment, until their reality stood firm enough for textbooks. A patient observer in Alaska contributed a new grammar for the eye. By layering thousands of hours of time-lapse and careful notes, he distinguished quiet arcs from explosive onsets, calm drifts from sudden poleward leaps. He gave the word substorm a home and described the way small disturbances rose and ran through the auroral oval like whispers crossing a hall before a chorus begins. The terms were modest, the measurements meticulous, the effect profound. The sky had not simply been catalogued, it had been given a behavioral language. Names kept joining the ledger. Pioneers in space plasma theory connected pieces that looked solitary. One researcher described how magnetic field lines from the solar wind could open and connect to Earth's field, letting energy enter like a tide through a gate. Another clarified the balance of ionized gas and magnetic pressure that belongs to planetary envelopes. Observers supplied the necessary proofs, printing sheets of plots that showed solar conditions, magnetospheric response, and auroral expansion aligned in time. Each stack of paper carried a quiet victory. The glow had surrendered another secret without losing any of its calm. In the later decades, measurements grew more intimate. Satellites flew in coordinated constellations, crossing the same field lines at different heights. Ground radars traced the motion of ionospheric plasma like weather radars trace rain. Networks of citizen cameras, separated by snowfields and coastlines, triangulated curls and folds with precision that would have astonished earlier generations. A new class of optical instruments evaluated the exact wavelengths of green, red, and purple emissions, converting color into temperature, composition, and altitude. The curtain had become a laboratory without walls. Yet the most calming discoveries were not only technical. Observers learned how often the aurora appears without drama. Small arcs gather over quiet lakes and hold their shape for hours. Soft patches drift like luminous mist and leave magnetic signatures so gentle they barely rise above background. The Earth is in frequent conversation with its star, and much of it occurs in whispers. The knowledge that the spectacle is persistent, that it goes on even when no one is watching, gives the sky the feeling of a reliable friend. Cultural understanding adapted alongside science. Communities in the high latitudes incorporated measurements into education without losing reverence. Museum halls kept photographs of delicate rays beside cases that hold magnetometer traces, inviting visitors to link emotion and evidence. Guides taught newcomers how to wait, how to avoid impatience, how to let eyes adapt, how to measure success in minutes of stillness rather than in bursts of intensity. The union of folklore and physics took on a graceful shape. Respect for the lights could sit beside calculations of their altitude and energy. The story of discovery is therefore a map of patience. It begins with fear and wonder, moves through names and instruments, and matures into patterns that can be forecast without killing their charm. A path of understanding now runs from elders who remembered green songs on winter nights to spacecraft that cross magnetic boundaries where the solar wind and Earth exchange momentum. Each step added clarity and removed superstition, and yet the calm sensation at the center survived every equation. Knowledge did not thin the beauty, it gave it context that deepened the breath. On a quiet, polar evening, an observer who knows this history feels a specific gratitude. The sky does not just glow, it communicates a chain of patient minds, of frozen fingers turning screws on tripods, of mathematicians aligning numbers with intuition, of explorers hauling instruments across ice in darkness, of engineers designing electronics that can endure the emptiness above air. A single arc carries all of that effort in its soft outline. The realization does not make the light heavier, it makes it kinder. The glow is a meeting place where human time, with all of its careful steps, meets planetary time, with all of its silent flows, and the result is a peace that can be felt in the lungs. Rules appear firm until night air glows without fire. A lifetime of kitchen and camp teaches that light comes from heat, that flames need oxygen, that brightness is noisy. The sky offers a corrective. Green and red bloom in air, far colder than winter ground, a cathedral of color built from particles that have never known warmth as the body knows it. The energy arrives not as temperature, but as speed and charge, carried by electrons that have fallen along magnetic lines. They collide with atoms and molecules and leave behind excited states that shine when they relax. The result violates habit. Cold emits, darkness brightens. A storm in space becomes a balm that seems to quiet thought. A second intuition falters with the silence. On Earth, bright discharges usually crack, hiss, or boom. Lightning lashes the ground and thunder follows with confident authority. Sparks snap when fingers touch a doorknob on dry days. The aurora carries currents large enough to sway compasses across continents, yet it speaks softly. The thin air at auroral heights cannot carry the pressure waves that would reach ears on the ground. Even when electrical fields accelerate electrons through kilovolts of potential, the release moves through a medium that barely collides. Magnetospheric storms close their circuits through the ionosphere, and the eye receives the message while the ear hears only wind or the padded hush of snow. Reports of faint crackles and whispers exist, but the physics of distance argues for illusions of simultaneity, local static effects, or sound produced close to observers by subtle coupling near the ground. The overwhelming rule remains that great currents can pass overhead in near silence. Color writes another set of exceptions. Atomic oxygen glows a particular green near 557.7 nanometers, a line that laboratory spectroscopists call forbidden. The term does not mean impossible, it means unlikely under normal collisional conditions. The excited state responsible has a lifetime of about 0.7 of a second, an eternity for an atom. At lower altitudes, such a patient state would be quenched by collisions before it could radiate. In the rarefied ceiling above about 100 kilometers, collisions are infrequent enough to allow that long breath to complete. The red oxygen line, near 630 nanometers, lingers even longer, roughly 100 seconds, which is why crimson veils tend to spread at higher altitudes, where the air is emptier still. Nitrogen molecules contribute purples and blues through band systems, with faster transitions, their patience shorter, their glow concentrated in lower layers, where collisions still permit radiation. The palette therefore inverts expectation. The slowest transitions live highest, the most delicate colors require the thinnest air. Motion challenges yet another expectation. Solar wind streams, reconnection jets, and magnetotail releases move at hundreds of kilometers per second. If auroras were direct pictures of that speed, they would flicker faster than a blink. Instead, the eye sees drapery that drifts, folds that ripple with seconds-long cadence, arcs that hold shape for minutes. The scale mismatch relaxes perception. Energy travels rapidly through the magnetosphere, but the display that results is filtered by the geometry of field lines, the inertia of ionospheric plasma, and the response time of chemical transitions. Particles descend in narrow funnels, shaped by magnetic lines, and create luminous sheets that trace those funnels. The waveguides of the planet slow the visible story to human speed. A tempest becomes a procession because field-aligned structure contains it. Turbulence usually eats patterns, yet auroras draw straight lines and razor-thin curtains across sky fields that ought to smear. Plasma is restless. Charged fluids support waves, vortices, and instabilities that shred gradients. The aurora respects boundaries as if a tailor had scored the night with chalk. The answer lies in anisotropy. The magnetized gas prefers to move along field lines rather than across them. Conductivity is high parallel to the field, smaller across it, and different again in the presence of drift. Pedersen and Hall currents combine to close circuits in the ionosphere, and the resulting flow organizes into channels. Where energy streams downward, The eye sees side-by-side sheets that keep their edges for long moments. Order grows out of directional preference. Geography itself violates casual expectation. The lights do not center on the geographic pole, and they do not form a tight circle. Instead, they collect in an oval displaced by the orientation of Earth's magnetic dipole and modified by the pressures of the solar wind. The oval expands during storms and contracts during quiet times, sometimes shifting longitudinally as the interplanetary magnetic field rotates. To a traveler who expects symmetry, the map surprises. Magnetic conjugacy links regions across hemispheres so that a disturbance in the southern oval often mirrors a partner in the north, with details shifted by the offset of the field. Two skies separated by oceans and continents share a choreography that a globe cannot show at a glance. Causality takes on a non-local flavor. What unfolds overhead is often triggered not above the head but tens of Earth radii down the magnetotail. There, magnetic fields, stressed by solar wind flow, store energy until topological changes allow a sudden release. The release launches flows and waves that race toward the planet and set up conditions for particle acceleration closer in. The glow begins where those accelerated electrons meet air. Eyes on a frozen lake look up at forms born far behind the night side of the planet. The same observer who trusts that lightning comes from the cloud above must accept that auroral brightness is an echo from a distant plasma engine. Even the sense of up and down becomes strange. Auroral rays appear to climb, but their verticality is optical. The shafts align with field lines that curve and twist, so the apparent straightness hides a complex path through space. Photographs show pillars that look like columns in a hall of light, yet they are slanted ropes that connect to space at distances the mind has trouble picturing. When the display rushes overhead in waves, the motion can feel like wind passing through a forest of vertical trunks, but the dynamic is an electromagnetic pulse skimming along a surface that wraps the planet. The body maps it to familiar forms in order to understand, and the mapping soothes. Time also rearranges itself. Many natural beauties reward a brief glance. A waterfall or a flowering tree reveals most of its detail in moments. The aurora guards secrets that only patience unlocks. The eye must adapt to darkness, to resolve the faint edges of folds. The slow brightening of an arc can take 10 minutes. The onset of a storm within the oval might require an hour of quiet watching before a sudden surge makes sense. This extended temporal grammar invites breathing to slow and the neck to tilt for longer than habit allows. The reward is a feeling that violates the hurried rule of modern attention. Relaxation arrives because the display demands it and returns it doubled. Soundless power teaches yet another contradiction. Instrument traces show currents of millions of amperes flowing along field lines into and out of the ionosphere. Potentials of tens of kilovolts accelerate swarms of electrons. Electric fields rearrange plasma over regions the size of continents. Such metrics suggest violence, yet the visible outcome glides. The reason is that power density, not total power, governs the immediate sensory impression. Spread across vast areas, the energy per square meter is modest, like sunlight softened by heavy cloud. What the mind perceives is gentle light distributed over a hemisphere, not the engine that fuels it. Human physiology contributes final inversions. The retina is tuned for dim luminance and finds comfort in the middle wavelengths where green lies. In scotopic and mesopic regimes, sensitivity curves favor the very band where oxygen glows brightest. The brain's motion detectors prefer slow drifts to strobing flashes, and the subtle sideward movement of folds triggers a restful pursuit response rather than jittered scanning. The nervous system, born to watch leaves and water, meets a sky that moves like leaves and water. Cells fire in patterns they associate with safety, and the result is an unforced calm that masks the cosmic scale of the driver. In each of these contradictions, a rule bends but does not break. Fireless brightness replaces flame, silence carries power, forbidden lines illuminate empty air, fast engines paint slow pages, turbulence draws hairline edges, distant triggers write local letters, vertical pillars hide curved chords. Long attention beats quick glances, massive currents feel light. Biology meets astrophysics and finds a comfortable handshake. The sum of these inversions produces the strange tranquility that settles on those who look up for long enough. What should be chaos looks like order because nature has chosen channels, heights, and timescales that translate a star's temper into a planet's lullaby. Closer scrutiny turned the sky into a ledger of numbers. Spectrometers split auroral light into narrow threads and wrote down the exact places where oxygen and nitrogen sing. The green line settled near 557.7 nanometers, with a width that told of altitude and temperature. The red line lingered near 630 nanometers and revealed heights where air grows so thin that excited atoms can keep their brightness alive for full seconds. Molecular nitrogen produced bands that braided blues and violets. From the relative strengths of these threads, researchers could reconstruct how energy arrived, how long it stayed, and which layers of the atmosphere welcomed it. Color stopped being only feeling. It became measurement. All sky cameras multiplied across tundra, islands, and boreal forests. Their lenses swallowed the dome and recorded night as yawning time. From each night came kiograms, those long ribbon plots where a single slice of the sky becomes a timeline. In them, arcs appeared as steady bars, surges as sudden inclines, poleward expansions as rising diagonals. With enough nights, statistics emerged. Quiet intervals lasted longer than memory suggests. Substorm onsets clustered around magnetic midnight. Curtains tended to form where conductivity gradients sharpened. A living weather of charged particles began to look predictable in the language of probability. Above the air, satellites drifted through the currents that eyes only infer. Particle detectors counted electrons and ions by energy and arrival angle. Field instruments traced the knots and tilts of magnetic lines as if reading Braille written in space. The numbers betrayed patterns in acceleration. Sometimes electrons arrived in beams with a characteristic inverted V signature in energy, a footprint of potential drops aligned with field lines. Sometimes they arrived in bursts modulated by oscillations, a sign that waves had carried them up the last steps of their descent. The sky below responded with different textures. Beams tended to carve crisp arcs. Wave-driven cases produced fluttering, a trembling of drapery that matched the frequencies measured aloft. Conjugate imaging allowed the planet to act like a mirror. Cameras in opposite hemispheres watched the same field lines from different continents. When a patch brightened in the north, its partner often brightened in the south, with a delay measured in the light travel time between hemispheres. Deviations from perfect symmetry spoke of local winds, seasonal chemistry, and the way the magnetic field is not a perfect bar magnet. The result was a sense of topology. Auroras mapped invisible pipes that connect far-apart landscapes and let one sky answer another. Radars that speak in radio waves traced the motion of ionospheric plasma. They measured drifts that followed electric fields and wrapped around the polar caps. From those drifts, one could reconstruct the potential pattern drawn by the solar wind across the magnetosphere. Two main cells appeared on quiet days, rotating like slow gears. During disturbed times, additional cells grew at the flanks, and the gears sped up. Curtains formed where flow shears compressed plasma or where upward currents threaded the air. The glow became a border marker between regions with different electric behavior. The beauty on camera corresponded to lines on a map of voltage. Incoherent scatter radars reached deeper. They listened to the faint whisper of thermal electrons and ions and teased out temperatures, densities, and composition at heights from the E region to the F region. During an onset, electron temperatures spiked thousands of degrees without burning flesh, because density is too small to carry heat downward quickly. Ion temperatures rose next. Then neutral winds responded as collisions passed momentum into the thicker air below. The chain of cause and effect ran from space to atmosphere, with a lag that could be timed in minutes. The glow that looked instantaneous carried a hidden schedule. Energetic neutral atom imaging opened another window. When fast ions stole electrons from neutrals, they turned into fast neutrals and flew in straight lines, indifferent to magnetic fields. Instruments could then make pictures of distant ring current populations by recording these neutral messengers. The pictures showed when the inner magnetosphere grew heavy with energy and when that energy bled away. Each growth phase fed the conditions that later produced widespread aurora. The camera that sees the invisible weight of space weather told why a quiet oval sometimes swelled into a belt of far-reaching brightness. Outflows from the upper atmosphere proved more important than expected. During strong sessions of light, oxygen and hydrogen ions climbed along field lines toward space. The process fed plasma into the magnetotail and changed the mixture that later re-entered the ionosphere. When oxygen joined the storm, dynamics shifted. Heavy ions modified waves and altered how energy could be stored and released. The aurora then bore subtle signatures of its own composition. Earth was not merely a receiver of particles. It supplied material to the very processes that made the sky glow. Short pulses in ground magnetometers arrived like footnotes to each display. Pi-2 pulsations chimed at the onset of substorms, a sign that the magnetotail had loosened its grip and that field lines had snapped into a new configuration. Traveling convection vortices rolled across the dayside during solar wind pressure changes. Field line resonances sang at discrete frequencies determined by local magnetic stiffness and mass density. Each oscillation had a face in the sky. The eye saw wavering arcs. The instruments heard particular notes. Together they completed the score. The energy budget grew clearer. By integrating particle fluxes and electric fields, one could tally how much power entered the ionosphere. During modest events, tens of gigawatts heated the upper air and drove currents that closed across continents. Larger storms lifted that tally by an order of magnitude. Yet, when spread across millions of square kilometers, the power density remained gentle on the scale of a few watts per square meter. That arithmetic explained the bodily impression. The engine roared in total, but the local touch felt like soft light. Fine structure came into focus as cameras improved. Thin rays within curtains aligned to within fractions of a degree with magnetic direction. Their spacing hinted at filamentary currents flowing in parallel. Sometimes, small beads dotted an arc before it broke into turbulence. Those beads resembled the early growth of an instability seeded by gradients across the plasma sheet or by resonance between drifting particles and field lines. High-speed recordings showed vortical curls along the lower edge of curtains where friction with neutral winds altered the flow. The drapery looked graceful because it obeyed equations that prefer elegant shapes under constraint. Distinct classes of aurora separated cleanly under detailed watching. Proton aurora glowed diffuse and smooth on the dayside when energetic protons entered and created neutral hydrogen emissions. Discrete electron aurora traced nightside arcs with sharp edges. Pulsating patches blinked in cadence with chorus waves trapped in the magnetosphere. Black aurora formed dark lanes where downward currents suppressed precipitation. Each type answered a different driver. Each type enriched the soothing confusion of the ordinary viewer with a taxonomy that made the calm deeper, not smaller. Timelines matured into choreography. A growth phase dimly loaded the magnetotail with energy, while a single arc held steady. An onset then brightened a short section near magnetic midnight and sent a surge poleward. Expansion followed with spreading curls and a rush of brightness. Recovery arrived as forms thinned and drifted away. The sequence could last half an hour or more, and each stage correlated with changing flows and fields above. Knowing the steps did not blunt the emotion. It turned suspense into understanding as a clock that has learned its own hands. Case studies brought surprises that revised comfort. A mauve ribbon aligned east to west appeared with a narrow green picket fence beneath it and carried temperatures in the upper atmosphere far above neighboring regions. Spectrometers found emissions dominated by a single structured line, and magnetometers recorded a sky-narrow conduit of flow. The phenomenon did not behave like common aurora and likely traced a distinct path for energy from the magnetosphere into air. This hinted that even within a matured map, secret tunnels exist. Across oceans of snow and sea, people and machines learned to listen together. A village camera would alert a team, a satellite would turn to catch a field line, a radar would sweep faster, and a magnetometer array would refine its cadence. The event would pass, and the data would pour into servers where algorithms searched for recurring shapes. The result was a new kind of memory that no single observer could hold. It carried the comfort of collaboration. The quiet sky had become a shared study. What this accumulation of data revealed most of all was the layered nature of serenity. The green arch that calms a face hides a precise structure of wavelengths, altitudes, and flows. The mild drift that soothes a spine rides on rapidly changing electric fields and currents that circle the globe. The apparent uniformity rests on filaments, beads, and curls that obey strict mathematics. The tranquil oval adjusts itself in step with winds from a star. Knowing these details did not spoil the peace. It gave reasons for the comfort, reasons that reached from the chemistry of thin air to the topology of near-Earth space. The night remained kind, and the kindness gained depth. Each year instruments improve, yet a core puzzle grows brighter. The display looks simple to the eye, but the engine that feeds it refuses simplicity. A single arc can hold its narrow edge for an hour, while a magnetosphere the size of a planet reconfigures. A razor line of green traces a path within a system full of vortices and waves that should smear any structure they touch. The longer observers watch, the more tightly the contradictions knit themselves together. Order appears where disorder ought to dominate, and that order changes its mind without warning. The first deepening arrives at the very start of many luminous nights. A dim arc lingers for long minutes with little change, as if waiting for a quiet instruction. Then, a brightening blooms in a small section, a kernel that swells and runs poleward. The suddenness of that spark has resisted full explanation. Two families of models compete in the data. One places the switch in the distant magnetotail, where reconnection breaks and reforms field lines, hurling flows toward the planet. The other places the switch closer to Earth, where currents within a heavy plasma sheet destabilize and throw energy into the ionosphere. Both produce convincing fingerprints in certain cases. Both fail cleanly in others. Night-side surveys collect thousands of onsets, and yet the exact trigger retains a veil that neither camera nor satellite has lifted for good. The second deepening concerns the way arcs keep their edges. In a medium of charged particles and fields, drift and diffusion should broaden any boundary. Instead, curtains draw even tighter filaments inside themselves, hairline rays aligned with magnetic direction like a comb held to the sky. One explanation appeals to feedback between electric fields, conductivity, and particle precipitation. Electrons brighten a slender region of ionosphere, raising its conductivity. The altered conductivity changes the pattern of currents and fields, herding even more electrons into the bright path and starving the surroundings. Positive feedback carves a track, and the track persists. Yet when this logic is coded into models, the simulated filaments still struggle to match the knife edges that real cameras see. Nature seems to run a more delicate balance than equations have captured. The third deepening takes shape in the beads that sometimes appear along an arc before it ruptures into turbulent forms. Each bead glows and fades with a rhythm that suggests an instability taking hold, like pearls along a string before it snaps. Some analyses favor a ballooning mode within the plasma sheet, a swelling driven by pressure gradients. Others find better agreement with a shear flow instability that curls like a river eddy when fast plasma glides past slower neighbors. Timing and spacing leave room for both. Different nights may choose different routes to the same visual symptom. The eye receives a row of lamp-like nodes and reads imminent change. The engine underneath wavers between candidates. A fourth deepening wears the face of darkness itself. Within broad sheets of glow, narrow lanes appear that look as if someone drew ink across the light. Instruments show downward currents in those lanes that seem to suppress electron precipitation. The dark streaks slither and branch, and occasionally encircle small islands of brightness. They are called black aurora, and their existence complicates any picture that treats the ionosphere as a simple screen. Something in the circuit can siphon energy away from regions only a few kilometers wide while neighboring patches grow. The fine-scale structure of electric fields and the role of upward and downward currents weaving past one another remains a frontier of patient work. Another layer of complexity rises in the dialogue between the upper atmosphere and space. Neutral winds in the thermosphere, driven by tides from below and by heating from above, push against ions that feel the magnetic field. Through collisions, The winds can rearrange ion drifts and alter where currents close. In turn, those currents heat the neutrals and change the winds they collided with. What appears as a luminous shape on camera may be the surface trace of a recursive conversation among particles that do and do not feel magnetism. Predicting this exchange requires models that couple fluids with different rules across heights that cover 100 kilometers and beyond. Small errors in that coupling grow quickly and shift the geometry of the glow. Time scales fracture into a puzzling ladder. Fast oscillations carry energy in Alfvén waves that bounce between magnetosphere and ionosphere in fractions of a second. Slower cycles drive convection cells around the polar caps over tens of minutes. Still slower phases energize and relax the ring current over days. Observations show crosstalk between these levels. A pulse at one end can unlock a change 2 rungs away. Drift waves can modulate the delivery of particles that then modulate chemistry, that then alters conductivity, that then tunes the reflection of the very waves that arrived first. The chain does not line up neatly. It curls back on itself and suggests a system that hovers near a state where small nudges can produce large, irregular results. The texture of pulsating aurora amplifies this impression. Patches blink on and off with periods of seconds and substructures that flicker faster within them. The light seems to take instructions from chorus waves trapped along magnetic paths, but the mapping between wave properties and the exact cadence of the patch often breaks under scrutiny. Sometimes the patch drifts with the plasma. Sometimes it holds place against the flow as if bolted to a particular field line. The contradictions pile up into a feeling that known ingredients combine in ways not yet fully written. Observers also meet forms that ripple like coastlines. Vast meanders, named for the last letter of the Greek alphabet, drift along the nightside oval and resemble the edges of continents drawn in pale ink. These waves often follow periods of quiet and signal recovery, yet they also coincide with flows that shear the ionosphere and with currents that establish new routes. Their spacing and speed point to large-scale instabilities in the coupled system, but the precise onset conditions vary so widely that prediction remains tentative. The eye enjoys their serenity. The mind knows that a long chain of causes fed them. A statistical portrait further complicates comfort. If one counts the sizes of brightening events or the intervals between onsets, distributions appear that lack a single favored scale. Modest flashes and grand expansions sit on the same curve. The pattern resembles the outputs of systems that organize themselves near a critical point, where avalanches large and small share a family resemblance. That suggestion is enticing because it explains why tiny changes sometimes birth large consequences, and why calm can break suddenly after long patience. Yet proof remains partial. The magnetosphere is forced from outside by solar wind conditions that themselves vary across scales, and the line between internal organization and external driving is subtle. The dayside creates its own riddles. Diffuse glows gather under the footprints of magnetic merging near noon, while discrete arcs can appear on the flanks where convection channels guide particles into narrow tracks. Sudden compressions of the magnetosphere under solar wind pressure shifts can trigger waves that sprint around the pole in minutes. Ground instruments hear their arrival as sudden impulses. Cameras see dim veils brighten and then settle as if a hand briefly pressed on the magnetospheric shell. The translation from mechanical shove to optical response involves a cascade through fields, flows, and chemistry that is still being untangled. Even altitude assigns new questions. Red forms high above can lie almost motionless, while bright green sheets below run with energy. The emissions do not simply add, they interact through radiation transport, quenching, and shadowing. A thin red cap can descend as composition changes, stealing light from below or enhancing it by altering the balance of collisions. Building a full three-dimensional picture of a single display requires coordinated instruments that sample multiple heights and directions at once. Such coverage is rare, and each night reveals details that do not fit neatly into previous nights. Perception contributes one more layer that deepens the mystery rather than dismissing it. The eye invents continuity across gaps and reads motion into sequences that may be driven by different causes. A viewer sees a surge and feels a wave pass, yet the light could have brightened by increased electron energy while the sheet itself stayed in place. Another viewer detects a drift that looks uniform, though instruments show alternating flows carving neighboring lanes in opposite directions. The mind is skilled at extracting meaning from sparse clues, a skill that comforts in the cold, but that same skill can hide the multiplicity of processes that share the vault. The paradox sharpens as understanding grows. Each advance in measurement turns the tranquil display into a richer network of cause and effect. The stability of a thin ribbon draws on feedbacks delicate enough to falter under small changes. The timing of a sudden onset keeps two grand engines in a quiet duel. The dark lanes within light require local circuits that invert intuition. Waves carry orders that sounds like lullabies but act like whips. Winds born far below, tilt currents born far above. Scales from meters to planetary radii overlap without apology. Serenity becomes a surface, stretched over a frame of restless physics. That frame resists a final diagram. It asks for mathematics that can host turbulence and order, for codes that can leap from nanoseconds of atomic transitions to hours of magnetospheric breathing, for observations that stitch together hemispheres and heights in the same minute. It asks for humility in the face of a sky that is easy to watch and difficult to explain. The deepening is not a loss. It is a gift that keeps curiosity alert while the body relaxes. A person standing under green drapery feels safe. A person tracing the chains that make that feeling finds a maze with many doors. The maze has no malice. It is simply large, and it invites patient steps. Ideas gather like constellations and ask to be traced. One picture begins at the dayside boundary, where the solar wind meets Earth's magnetic shield. When magnetic fields carried by the solar wind tilt southward, they can join with the planet's field in a process called reconnection. Topology changes in a blink. Field lines once closed now open to interplanetary space. Solar wind flow drags these open lines over the poles and stretches them deep into the night side, building a magnetic tail loaded with tension and plasma. Far behind the planet, more reconnection closes the lines again and snaps them forward. Energy stored in the tail becomes motion and heat. This view, named for a steady cycle of opening and closing, explains continuous convection and a supply of particles that later rain into the atmosphere as light. It is a clean map that turns a turbulent boundary into a pathway for energy. A second sketch puts a spotlight on the night side, near where closed field lines begin. In this region, a plasma sheet thickens and heavy with stored energy. As conditions slowly change, current there may destabilize. The current can break into a wedge that diverts along field lines into the ionosphere and back, altering the balance of forces across a large volume. When that current relaxes, magnetic field lines snap inward and energy rushes earthward. The reconfigured paths favor acceleration of electrons into the upper atmosphere, and a sudden brightening follows. Advocates of this view read ground magnetometer patterns and see geometry that matches the shape of a current wedge. The auroral onset in this picture is an electrical relief, a system exhaling after holding tension too long. Others place the key change farther down the magnetic tail. Reconnection there would create a near-Earth neutral line and launch high-speed flows toward the planet. As those flows meet stronger magnetic fields closer in, they break, pile up, and divert around a barrier like water meeting a rock. The braking and diversion excite waves and instabilities that accelerate particles into narrow channels. Bright arcs and poleward surges follow the path of these returning jets, and the timing fits many observed onsets. In this view, the magnetotail is a factory that stamps out packets of energy and hurls them home. All three pictures can be true on different nights. The system likely chooses among them depending on solar wind pressure, field orientation, plasma composition, and the history of the magnetosphere in the preceding hours. Theories interleave rather than cancel. Reality may braid them together in a sequence that varies from event to event. The common trait is the organization of energy into structures that prefer narrow lanes and decisive moments. Exactly the traits the eye reads as a calming clarity. Even with a driver identified, the last meter before light remains an open field for ideas. Electric potentials aligned with magnetic field lines can drop tens of kilovolts along narrow corridors, and electrons falling through these corridors gain energy that allows them to excite oxygen and nitrogen efficiently. The shape of those potentials is debated. Some measurements favor quasi-static double layers with sharp edges, like steps carved into space. Others find signatures of Alfvén waves carrying energy that transforms gradually into particle motion through dispersive effects. In the wave picture, the acceleration is a rhythm rather than a step, and the glow flickers in sync with the wave's period. Many nights exhibit both behaviors in different places, a reminder that space can host multiple instruments in the same orchestra. At the scale of filaments, a feedback model gains traction. Where precipitation brightens a ribbon, ionospheric conductivity increases. The current system seeks the path of least resistance, focuses into the brighter region, and strengthens the fields that invite more precipitation. The self-sharpening continues until resistance from surrounding flows and from finite particle supply halts it. The result is a long, thin lane that can persist. Numerical experiments show such lanes, but reproducing the exquisitely straight edges and the long lifetimes seen from the ground remains difficult. Improved coupling between ion motion, neutral winds, and magnetic fields may make the lanes in models as tidy as the ones in the sky. Fragments of order sometimes break into rows of beads. Theories for these precursors to rupture include pressure-driven ballooning in the midtail, shear instabilities at the boundary between fast and slow flows, and resonant coupling between drifting particles and standing oscillations of field lines. Each theory predicts a characteristic spacing and growth rate. Observations find several families of spacing, suggesting that multiple instabilities can take turns on the same night. The beaded arc then becomes a diagnosis, rather than a single symptom, a way to read the state of distant plasma without leaving the ground. Pulsating patches open another window on mechanisms. They blink with periods of seconds and carry faster substructures. Links to Whistler mode chorus waves drift through the data. In this view, trapped electrons in the outer magnetosphere interact with those waves, scatter into loss cones, and rain into the atmosphere in modulated bursts. The patch then becomes a map of wave-particle conversations happening thousands of kilometers away. The cadence varies with wave properties, local magnetic geometry, and the presence of heavier ions. Theories match many cases well. Yet stubborn mismatches remain where patches hold place against drifting plasma or where the on-off contrast exceeds expectations. Dayside forms have their own speculative machinery. At the boundary where the solar wind glances past, velocity shear can excite Kelvin-Helmholtz waves that roll like clouds along a mountain range. These rolls may feed reconnection by mixing plasma and twisting field lines. Flux transfer events, brief magnetic bridges between the solar wind and Earth, could punctuate the noon region with bursts of entry. Each bridge would march across the dayside and leave a footprint that cameras could catch as a faint, moving glow. Theories argue over how often these bridges form and how much energy they deliver, but the images of drifting knots and swirls support the idea that dayside serenity is stitched by many small handshakes. A quiet oddity invites new thinking near the equatorward edge of the auroral zone. A narrow mauve ribbon can appear far from the main oval, accompanied by a picket fence of green at lower altitude. Instruments find extremely fast westward ion drifts and a thin conduit of heated air and enhanced emissions that do not look like typical electron precipitation. A speculation gains strength that this ribbon marks a subauroral pathway where strong electric fields accelerate ions and heat neutrals through friction, producing optical signatures without the usual rain of electrons. If true, the ribbon is a window into a different route for energy to reach the atmosphere, one that skirts the usual pipelines along field lines. Heavy ions emerging from the upper atmosphere add another thread to the tapestry. When oxygen ions climb into space and join the magnetotail, they change the mass of the plasma and influence how waves propagate and where energy can gather. Models that include this outflow can shift the balance between competing onset mechanisms. The presence of oxygen tends to thicken current layers and alter the stability of both reconnection and current-driven processes. Nights with strong outflow may therefore favor one path to aurora over another, a subtle choice that spectrometers on the ground can sense in the ratio of colors. A broader speculation leans on patterns in statistics. Distributions of event sizes and durations in the auroral ionosphere often resemble those produced by systems that self-organize near a critical state. In this view, the magnetosphere acts like a pile of sand built by a steady hand. Sand grains fall, and small slopes adjust quietly until an accidental grain unleashes a cascade that runs far. The model produces power, law, statistics, and bursts of all sizes. It is attractive because it explains sudden change after long calm and the absence of a preferred scale. Critics point out that the magnetosphere is forced by a wind that already varies irregularly, and that separating internal avalanches from external shoves is challenging. The truth may honor both, with the system hovering in a condition where the wind's smallest features can trigger a full reorganization. Theories that couple vision and physiology add a final layering. Some researchers borrow ideas from fractal geometry and efficient coding in the brain. The drapery of Aurora often exhibits scale-free edges and gently correlated motion. The visual cortex is tuned to extract order from such statistics with minimal strain. The eye thus experiences the display as restful because it matches the brain's preferred patterns for natural scenes like waves and leaves. This suggestion complements the physics rather than competing with it. A star and a planet arrange conditions for soft light. A nervous system evolved to find comfort in similar textures receives the message gladly. No single explanation has earned the right to stand alone. The magnetosphere is a compound instrument, and auroras are its score written on air. Reconnection feeds the staff with open notes. Current disruption, flow breaking, and waves write the melody and harmony. Feedback in the ionosphere sharpens the clefs. Heavy ions deepen the timbre. Special pathways add counterpoint. The performance changes with solar wind tempo and with the slowly shifting alignment of the magnetic field. Theories refine the parts and test them against the night, until the arrangement held in equations hums like the glow that looks so calm to a watching face. The instruments assemble like a quiet orchestra around the poles. Each device listens to a different register of the same sky, and together they turn radiance into evidence. Glass domes shelter all sky cameras that drink the entire vault at once. Their lenses gather green and red and violet and spread them into nightly tapestries. From these tapestries, kiograms unroll as narrow bands of time, a longitudinal heartbeat for the auroral oval. Nearby, narrow field images keep watch on one arc as if guarding a flame. Photometers count photons with a patience that never tires. Spectrographs step between wavelengths and weigh the light, telling oxygen apart from nitrogen, tall heights from lower ones, quick emissions from long-lived afterglows. Fabry-Perot interferometers read the faint Doppler shift of airglow and auroral lines to infer winds and temperatures where aircraft never fly. The sky becomes a laboratory where motion leaves fingerprints in color. Across snow and rock, arrays of magnetometers sink their feet into soil and bedrock. Each magnetometer holds a demure needle or a triaxial sensor that feels disturbances from currents aloft. When field-aligned currents surge, the needles tilt together. When the oval expands, the tilt migrates as a wave across a continent. These data turn graceful light into maps of electric rivers. The maps do not dazzle the eye, but they are the grammar that lets models speak to observation. Radars add a distinct voice. Coherent scatter networks send short radio pulses into the high latitudes and listen for whispers from drifting irregularities in the ionosphere. From the return, they reconstruct the wind of charged particles and the pattern of electric potential across the polar caps. On quiet days, two cells rotate like patient gears. On disturbed nights, the pattern twists and multiplies. Incoherent scatter radars go deeper, teasing out densities and temperatures for electrons and ions, and the speed at which neutrals exchange momentum with them. The numbers carry the story of heating and cooling, of collisions that do not burn skin yet shape entire skies. Satellites turn the vertical dimension into a set of measured steps. Some skim the ionosphere and carry particle detectors that count electrons as they plunge along field lines. Others sweep through the inner magnetosphere, where waves and trapped particles barter energy. There are craft that hover near the boundary with the solar wind, monitoring the pressure and magnetic orientation that prime the whole system. Farther out, constellations of spacecraft drift in the magnetotail where reconnection can erupt and flows can sprint homeward. The choreography requires timing. When a flow leaves the tail and hits a barrier closer to Earth, a bright surge may trace it minutes later. Instruments aloft and lenses below compare their clocks and confirm that a distant rearrangement wrote a line of light above a lake. Sounding rockets supply the most intimate look. Launched into specific arcs with a precision that strains logistics, they rise along field lines and pass through the very filaments that photographers admire. Onboard experiments sample electrons and ions with sub-second cadence, measure electric fields at small scales, and capture waveforms whose patterns last only heartbeats. The flights are brief, the payoff is large. For a few hundred seconds, the instruments sit inside the luminous machinery and the numbers speak without intermediaries. Tomographic methods turn many small views into one deep picture. Networks of cameras separated by tens of kilometers record a shared arc. Algorithms then reconstruct volume emission rates, recovering the vertical profile of the glow. The result is a three-dimensional slice through the curtain that shows where green peaks, where red lingers, and where nitrogen's blues curl along the base. When combined with magnetic models, the slice becomes a map of the field line that carried the particles, along with the altitude where their energy dissipated. Each reconstruction is a glimpse of form inside radiance. Navigation satellites that were built for positioning become tools for sky physics without altering their orbits. As their signals cross the auroral zone, the total electron content shifts. Receivers on the ground watch these changes and produce maps of plasma density. Scintillation reveals small-scale structures that disturb radio links and betray turbulence in the ionosphere. The same network that guides a snowmobile across a fjord signals the edges of a growing substorm and the onset of ripples within the charged air. Laboratories on Earth reproduce fragments of the sky, with magnetic fields and plasmas contained in long chambers. In those chambers, reconnection can be initiated at will, and the resulting jets and waves can be measured with probes that would never survive in space. Microwave and laser diagnostics record how energy leaves a magnetic storehouse and becomes flows and heat. The scale is smaller, the physics the same. When a probe detects a burst of alphenic energy in a lab, theorists compare it with waveforms logged by satellites and propose mechanisms for the way electrons ride those waves toward air. Models knit the strands together. Global magnetohydrodynamic codes simulate the magnetosphere as a fluid tied to magnetic fields. They ingest real solar wind data for boundary conditions and evolve the result forward in time. Inner magnetosphere models track the ring current and radiation belts where trapped particles form a shifting society. Ionosphere and thermosphere models calculate winds, densities, and chemistry where air and plasma mingle. Data assimilation techniques feed observations back into the models to correct their paths, like a sailor adjusting a course with new bearings. Ensemble methods run many parallel simulations to estimate uncertainty as conditions evolve. Forecasting becomes a discipline rather than a wish, and the strange serenity of the sky gains a modest, useful predictability. Machine learning turns archives into anticipations. Decades of images and magnetometer records train networks to recognize the signatures that precede a surge. The networks do not derive equations. They reflect patterns too tangled for analytic pen. When a certain swirl appears in solar wind data streaming from the upstream monitors, the model raises the odds of an expansion at a given longitude. When a beaded texture takes shape in an arc, a classifier votes for imminent rupture. The predictions still err, but they are guideposts for travelers and instrument teams who wish to aim eyes and rockets where the sky will most likely awaken. Citizen networks turn curiosity into coverage. Thousands of small cameras and countless hands with phones return images from farms, villages, ice roads, and ship decks. Alert systems notify watchers when a rise in current or a rotation in the interplanetary magnetic field makes a display likely. Reports fill maps with real-time sightings that complement professional stations. Photographs carry embedded data that reveal orientation, lens response, and exposure. With calibration, these images become measurements rather than souvenirs. The sky gains many eyes, and the data gain the texture of lived experience. International campaigns stitch every tool into one garment. Weeks are chosen when orbital alignments promise coordinated passes, when darkness favors the poles, and when the sun is likely to stir. Schedules for satellites, rockets, radars, cameras, and ground arrays are aligned like dancers on marked floorboards. When the night arrives, one instrument hears a chorus of waves in the magnetotail, another watches flows change in the polar cap, a third sees an arc sharpen, and a fourth measures ion temperatures rising. The ensemble yields a chain of cause and effect stitched from minutes and kilometers, and a paragraph is added to the planet's ongoing manual. Calibration anchors the craft. Cameras must be checked against standard stars to correct their sensitivities. Spectrometers must be compared against laboratory lamps. Magnetometers must be zeroed and protected from local metal. Radars must confirm their pointing and power. Satellites must know their position and attitude with exquisite care. Without such housekeeping, poetry strays from truth. With it, beauty and accuracy travel together. Uncertainty is not an enemy in this work. It is a companion that is quantified and reported. Bars on plots represent what is known and what is not. Ensembles speak in probabilities. Forecasts issue ranges rather than declarations. The humility coded into these choices is part of the relaxation that the lights inspire. Knowledge here grows steadily without pretending to finish itself. Plans for the next decade sparkle with ambition. Constellations of small satellites will carry magnetometers and particle detectors on many field lines at once, turning the magnetosphere into a mesh that resolves fine scales. New radars will fill gaps in coverage over oceans, linking continents with beams that cross polar night. Interferometric optical arrays will measure the rapid flicker of thin rays with millisecond precision. Rockets will target peculiar forms that still keep their secrets, diving through mauve ribbons and black lanes to sample unusual fields. Models will couple deep atmosphere to space with higher fidelity, tying tides and planetary waves to auroral timing. Machine learning systems will move from classification to actionable guidance for power grids and aviation. Through all this, the purpose remains simple. Instruments exist to keep company with a sky that gives comfort and instruction. The technology grows elaborate because the subject is generous instead of simple. Each new tool adds a note to the chord and a question to pursue, and each night distributes both to those who listen. The green drapery is fragile at the eye yet robust in its lessons. It welcomes the tripod and the rocket, the code and the pencil, and the many hands that steady them. It rewards patience with clarity and labor with glimpses of order inside motion. Measurement, in this realm, is a kind of gratitude paid back to light. Energy can travel like a whisper when it rides a magnetic string. In the cold, sparse plasma above the polar atmosphere, a kind of wave moves without breaking the silence. It does not shove matter aside the way sound does. It tugs at magnetic field lines as if plucking taut cords that thread space. The restoring force is magnetic tension, the inertia is the mass of ions and electrons caught in the field, and the result is a transverse oscillation that slides along the invisible rope. This is an Alphen wave, and its speed is set by the strength of the field and the lightness of the plasma. Where the field is strong and the gas is thin, it races. Where the field relaxes and the gas grows heavier, it slows. Every path from the distant magnetosphere to the upper air has its own tempo. These waves carry energy in their electric and magnetic variations. The flow of power is guided along field lines and leaks only grudgingly across them. In a simplified view, they are elastic messages from one region to another. A disturbance in the magnetotail, or on the boundary that faces the solar wind, can launch packets that slide planetward in seconds. Once they reach lower altitudes, gradients in density and field strength reflect part of their energy back upward. The rest continues downward, where it encounters the conducting layer of the ionosphere and deposits a share of its cargo as heat, motion, and acceleration. A single line can act like a resonant cavity, trapping oscillations that bounce between hemispheres until friction and coupling to particles drain them away. Resonance gives these paths a voice. Each line has a preferred set of frequencies, a spectrum set by its length, field strength, and the distribution of mass along it. When external forcing matches one of these frequencies, the line answers with larger amplitude. Ground magnetometers hear the reply as a periodic wiggle of the local field. Cameras notice a gentle wavering in thin arcs. Satellites notice that particle distributions and electric fields pulse in step. The planet's magnetic architecture becomes a set of organ pipes that the solar wind can play. Ideal oscillations are not enough to light a sky. A mechanism is needed to turn the wave energy into particle energy directed along the field. In the simplest theory, alpha waves carry no electric field along the line and cannot accelerate electrons parallel to it. Reality is less shy. At scales small enough that the wave varies appreciably over a few kilometers, inertia and thermal motion break the ideal constraint, and a parallel electric field appears. These are inertial and kinetic alpha waves. Their electric component points along the field line and can accelerate electrons downward. The electrons gain a few kilo-electron-volts, enough to excite oxygen and nitrogen efficiently. The glow that results may flicker in the rhythm of the wave that fed it. Wave-particle interactions add finesse. Electrons drifting along field lines can exchange energy with a wave if their motion matches the wave's phase speed in the relevant direction. In such a resonance, the wave trades a slice of its energy for a change in the particle's velocity. If many electrons borrow the same kind of slice, the wave attenuates and the precipitation grows. The details depend on local density, magnetic curvature, and the presence of heavier ions that modify the dispersion. The same field line can host a clean standing resonance 1 hour and a damped, patchy pattern the next, depending on how air has been lifted or heated. Observations show several phases of this process. During calm intervals, long-period oscillations gently modulate thin arcs, producing an almost metronomic sway across the sky. During active times, faster waves arrive that carry sharper electric gradients and accelerate electrons in bursts. Rocket flights through such conditions record spikes in parallel electric field only a few kilometers wide. The narrowness is important. It means the waves have shrunk to scales where inertia and finite temperature matter. In those intervals, the luminous curtain acquires a texture of pulsing and rippling along its edge, a visual record of electrons being fed in packets instead of streams. Some waves appear to arrive as couriers from breaking plasma flows closer to Earth. When a jet from the magnetotail runs into stronger fields and diverts, a portion of its kinetic energy is converted into alphenic pulses. The pulses sprint along field lines and reach the ionosphere before the broader reconfiguration completes. Cameras then catch an early tremor of light before the main surge. Ground stations record magnetic pulsations with discrete frequencies that match the expected resonance for the local field line. The idea of a call and response is not metaphor here. It is timing written in numbers. The coupling to the ionosphere determines how the wave spends itself. In regions where the conducting layer is strong, a larger fraction of the wave energy reflects, and a smaller fraction becomes heat or particle acceleration. In regions where conductivity is weaker, more energy penetrates and is absorbed. Conductivity itself depends on prior precipitation, neutral winds, and solar illumination. The wave therefore finds a moving target. It adjusts without intent, delivering its envelope of energy according to the shifting state of the air. The aerial music changes key as it enters different halls. The presence of oxygen ions lofted from the upper atmosphere can alter this music. Heavy ions slow the wave and change the relationship between perpendicular and parallel electric components. In some cases, they increase the ability of the wave to create parallel fields and thus to accelerate electrons. In other cases, they detune the resonance and suppress acceleration. Nights with strong outflow can therefore drift toward flickering forms favored by kinetic waves, while nights with light outflow may lean towards steadier arcs shaped by quasi-static potentials. Spectral measurements of color can hint at which path has been chosen, since different energies of electrons create different ratios of green to red and different contributions from nitrogen bands. Field line resonance is not the only alphanic note. Shorter wavelength variants ride on larger structures like embroidery on fabric. These finer waves can be generated by shear at the edges of flowing channels in the ionosphere by gradients along the boundary between open and closed field lines, or by turbulence cascading from larger scales. The small scales are efficient at accelerating electrons because their parallel electric fields are most pronounced. They also interact more strongly with neutral winds through friction and can heat the upper air in narrow lanes. Cameras sometimes reveal this as picket fence structures beneath a high-altitude arc, a row of short, vertical rungs that flash in rapid succession. Perception grants these waves a gentle authority. The eye does not resolve the kilohertz chatter of microscopic fields. It registers the integrated result as a breath-like undulation. The strongest standing resonances often sit in a frequency band between tens of seconds and a few minutes, a band that coincides with natural rhythms of attention and with slow patterns in heartbeat and breathing at rest. Without imposing anything mystical, it is fair to say that the cadence of many alphanic modulations falls where a watching mind can follow without fatigue. The body relaxes into a pace it knows how to hold. Ground instruments translate this comfort into plots that look like steady hands. Magnetometers draw sinusoids when a field line rings cleanly. Photometers trace smooth rises and falls as emission strengths follow the envelope of the wave. Radars see plasma drift oscillate back and forth in perfect time. When multiple stations align along a meridian, the phase shifts from one to the next, reveal the standing nature of the oscillation and the nodes and antinodes of the imagined string. The agreement across devices is a quiet satisfaction. It furnishes a physical basis for the calm textures that the eye enjoys. In the equatorward portion of the oval, waves sometimes degenerate into fine-scale turbulence that still retains an alphanic heart. There, the distinction between wave and structure blurs, and small parallel fields form and vanish quickly. The auroral light in such regions can tremble at the edge of visibility. These are not the stately motions of large resonances, but the shiver of a plucked chord fading to silence. Even in this restless end state, the music remains more lullaby than drumbeat. What arrives at the end of the chain is not a single mechanism, but a family resemblance among processes that move with softness along magnetic rails. Alphan waves are messengers that carry power from places where field lines rearrange to places where electrons touch atoms. They allow energy to travel quickly without erupting into noise. They choose scales and rhythms that the visual system finds comprehensible. They modulate the curtain, add pulse to the drape, and give gentle structure to long nights. A watcher standing beneath their work will not hear them, yet will feel their order in the swaying of color. It is one of nature's quieter negotiations, a contract between storm and sanctuary written in oscillations that prefer grace. There exists a rhythm that only long nights reveal. It begins as a faint arch holding steady above dark forests, then turns into a decision. A small bright seed ignites near magnetic midnight, and from that seed a surge runs poleward, as if the sky had finally taken a breath it had been postponing. Magnetometers far below register a new pull as currents strengthen along the auroral electrojet. Cameras catch a scalloped front that advances like a tide across wet sand. This is a substorm, the basic pulse of near-Earth space. It does not measure itself in thunder. It writes in light and electric flow, and it treats silence as a stage rather than an absence. The pattern often unfolds in 3 chapters. A growth phase lasts tens of minutes while the nightside magnetotail loads with energy. A single arc holds its place with the patience of a waiting line. The onset arrives in a small sector near midnight. Brightness intensifies, the arc thickens and breaks into folds, and a westward traveling surge curls like the prow of a slow ship along the oval. The expansion phase follows as arcs multiply and race poleward. A recovery then takes over as the shapes thin and drift. The electrojet relaxes, and stars reappear through faint veils. The viewer, reading only with eyes, senses a slow exhale. Instruments record a chain of field reconfigurations and currents that would be loud if they had sound. In such a pulse, the geometry of the auroral oval changes its footprint across continents. The oval broadens and slides, centering itself on the magnetic pole rather than the geographic one, and moving in sympathy with the orientation of interplanetary magnetic fields and the pressure of the solar wind. During expansion, the equatorward border can step toward lower latitudes, inviting towns that sleep under ordinary stars to wake to a pale arc. A river city, at 45 degrees, may find a green band above its northern horizon and a crowd gathering on bridges. The local quiet deepens even as the scale of the event grows. People speak softly because the sky suggests it. When energy arrival intensifies over days rather than hours, the night writes a larger score. Electric currents wrap deeper into the inner magnetosphere and build a ring of trapped particles that circles the planet. Indices designed to summarize this weight sink into negative numbers as the ring current grows and the main field weakens a little at the surface. The oval swells far toward the equator, sometimes revealing green pincers around old stone cathedrals and small towns that have no word for curtains in the sky. This is a geomagnetic storm. It carries many substorms within it, a nested sequence of pulses riding on a global rearrangement. The effect on watchers is simple. Streets empty, fields fill, and breath slows while light runs across cloudless vaults in long files. Different forms favor different parts of this largeness. Stable red arcs can appear at mid-latitudes during long-lasting storms, thin bands of crimson that hover near 150 to 300 kilometers in height. They trace regions of heat deposited in the upper atmosphere where oxygen radiates slowly. Their color is wine held up to starlight, and their motion is minimal. They can persist for hours like a quiet thought. Discrete green curtains prefer higher latitudes and lower heights, where electrons arrive with energies tuned to quick oxygen transitions and molecular nitrogen bands. Diffuse glows broaden the daylight side where protons and scattered electrons enter without carving sharp lines. Each type carries its own pacing, and the sum of them enlarges the sensation of stillness by distributing movement over scales that never rush. The electrojet that closes currents in the ionosphere strengthens during expansions. Its eastward and westward limbs draw loops around the polar caps like electrical belts that tighten and relax. Ground instruments that measure changes in field direction feel those belts as pressure on their needles, a pressure that drifts with each surge. The belts heat the upper air through friction and collisions. Neutral winds respond and begin to flow along newly created pressure gradients. This slow rearrangement carries its own serenity. The air at 100 kilometers moves without gusts that the skin could feel, yet its paths are as definite as rivers. The light below hints at their progress. Timing within the surge has features that storytellers cherish. The westward traveling front often marches with a repeating scallop that repeats every few hundred kilometers. Small beads line the edge early, then stretch into streamers that peel away toward the pole like ribbons pulled from a bundle. Some streamers split and reconnect, weaving the sky with a pattern that mirrors flows in the magnetotail. The continuity between distant reconfiguration and local light becomes visible to patients. A child who watches closely can predict where the next thread will run just by how the last one moved. The predictability inside a restless process stabilizes attention and adds to the calm. Storms that ring the entire planet alter everyday instruments that no one watches at midnight. Compasses drift gently, radio signals scatter. The power grid feels currents induced in long lines. Aircraft alter routes to avoid polar regions where communication can falter. The human presence in these adjustments remains hushed. Engineers monitor, pilots refile, controllers reroute. On the ground, watchers under the curtains do not perceive the quiet room full of decisions. That disjunction adds to the paradox. A display that calms the body coexists with a system-wide alert in the machines that keep modern life stable. Even in the midst of strong activity, the eye discovers islands of rest. Between streamers, there are broad lanes where nothing seems to happen for many minutes. In the lower sky, a faint glow hangs like fog and takes so long to change that the mind loses track of time. Near the zenith, a soft swirl remains anchored as if the air had found a gentle eddy and refused to leave. These quiescent patches result from geometry and supply. Field lines that do not connect to a source of accelerated electrons will not light, and regions where currents close without strong precipitation will remain dark. The irregularity in feeding produces the regular gift of stillness inside spectacle. The scale of perception matters. A camera with a wide lens sees slow drifts. A camera with a tight lens sees quick ripples. The visual system without equipment chooses a comfortable field of view and generates a composite. It tracks the front, registers the drift, feels the slow fade, notices the sudden puncture of a streamer, and then returns to a long arc that has not moved. That layering of speeds aligns with human comfort. Rapid flicker would fatigue. Absolute stillness would bore. The mix of steady bass and intermittent accents holds attention without taxing it. Auroral pacing is a kindness built out of physics. There is also a grace in how events close. Geomagnetic storms do not end with a bang. They taper as the solar driver rotates away or relaxes. The ring current decays as particles scatter and drift outward or inward and are lost. The oval contracts. Where small towns enjoyed their first glimpse of green, the horizon returns to the color of night. At high latitudes, soft arcs continue under stars with a confidence that daily life will always respect. The withdrawal is courteous. It leaves quiet behind, rather than emptiness. A single watcher in a field may misjudge the size of what passes overhead. The elegant flow of light invites inwardness. Yet maps the next day reveal that a surge touched a dozen countries at once, that forecasts predicted the arrival of southward magnetic fields hours before, that a chorus of instruments recorded coherent pulses across ocean-width baselines. The personal calm sits inside a planetary experience. This nested feeling is at the heart of why such nights restore. The individual body aligns with a system too large to grasp and discovers a tempo that feels right. Snow and water do their part. Snow reflects green with a silky softness that removes harsh contrast from the scene. Frozen lakes amplify the light and spread it wider without glare. Mountains blacken into silhouettes that steady the eye against the moving vault. The world beneath the show becomes a perfect auditorium, damped and cool, with no objects clamoring for attention. Even city dwellers who drive to dark beaches or quiet ridges find that the elements clear the stage for sky. The resulting composition is balance itself. The calm has one more source that instruments will never quantify. The fact that a star and a planet are in extended conversation, and that this conversation translates into beauty rather than violence at the surface, carries psychological relief. The shield holds. The energy that might strip away air arrives as a mindful glow instead. On a night when the oval spreads and streamers race, nothing breaks at the feet. The mind anchors to that assurance. Bodies release tension they did not know they held. The quiet is not a void, it is confirmation. In the taxonomy of space weather, substorms and storms are categories with thresholds and indices. In the inner life of a person standing under them, they are modulations of breath and focus. Small pulses rehearse the ability to wait. Large envelopes of activity rehearse the ability to accept change without fear. Both deliver gentle instruction that lingers long after cameras are packed. The instruction is that vast processes can be graceful when mediated through protective fields and thin air. A watcher leaves the field with muscles unwound and a pace newly learned, as if his own electrojet had loosened. The next day looks different because the night taught a lesson without speaking. Oddities gather at the edge of the oval like quiet guests who arrive after the music softens. The first to step forward is a mauve ribbon that refuses the rules of common green drapery. It draws a straight path from east to west across the subauroral sky, sometimes stretching from horizon to horizon as if measured with a ruler held by a patient hand. Its color leans toward lavender, sometimes salmon pink, with a narrow waist that does not fray. Beneath it, short green pickets rise and fall in a repeating fence that seems to tap the air in place. The ribbon glides westward with the confidence of a river that has found a channel carved for it alone. This is the feature that watchers choose to name with a simple human word, a name that fits its gentle surprise. Instruments near the ribbon detect ion drift so fast they redraw local maps of motion. Temperatures climb in a narrow corridor of the upper atmosphere, as if friction has warmed a path that only electrons and ions can feel. The light is not created by the usual rain of energetic electrons along magnetic lines. It is a signature of rapid flow and heating in a region just equatorward of the familiar oval, an afterglow of air rubbed by accelerated charge. The picket fence below the ribbon hints at wave structure, small vertical rungs that pulse one after another like footsteps on a narrow stair. Together they form a layered composition. The ribbon announces a fast conduit. The pickets decorate its underside with the cadence of a quiet drum. Another visitor prefers daylight and smooth outlines. Protons that descend into the dayside atmosphere do not carve sharp sheets like their electron cousins. They exchange charge with neutrals and reveal themselves through soft emissions that blend across wide regions. Seen by sensitive cameras, the dayside takes on a diffuse bloom, a milk glass sheen that changes with the pressure of the solar wind. It looks like a memory of light rather than the thing itself. The softness is the point. It signals that the sky has accepted a different kind of guest, one that writes in whispers. A more theatrical figure crosses the polar cap and draws a bar through the crown of night. A transpolar arc links the dusky side and the dawn side like a bridge of pale green. When such an arc brightens, the polar cap resembles a letter traced by an unhurried pen. The shape announces a topological change in the magnetic connections overhead. Field lines that normally open to interplanetary space have folded into a loop that closes again. The path becomes a gallery where electrons find their way without following the standard map. Watchers beneath the arc feel the hush of a rare crossing, and the comfort that comes from seeing geometry declare itself. Quieter still are the crimson bands that appear far from the bustling oval during long disturbances. Thin red lines hover for hours at heights where oxygen releases light only after long patience. They hang above farmland and cities unused to auroral speech, and their steadiness encourages standing and staring rather than rushing and pointing. The red carries the tempo of a held note. Even the word for these forms sounds like repose. They mark heat stored in the upper atmosphere and trickled back out in long breaths. For those who meet them without prior expectation, the impression is of a sky that has learned to speak softly in a new dialect. There are nights when the familiar curtain becomes scalloped and develops heads shaped like the letter at the end of the Greek alphabet. These heads march eastward in a row, their bases tethered to the main band, and their tops swelling into rounded lobes that recall gentle surf. Below them, the lower edge of the curtain ripples with organized folds that repeat across hundreds of kilometers. The rhythm is slow enough to follow without fatigue. The arrangement hints at large-scale waves in the coupled system, a comfortingly regular pattern inside wider commotion. An even more delicate phenomenon appears as a sequence of evenly spaced stripes in the green light of oxygen, running from horizon to horizon, with the order of a comb pressed into sand. The stripes sit at a height lower than many auroral forms, near the ceiling where meteors burn and tides from the lower atmosphere can leave their mark. The spacing suggests a waveguide in the thin air, a duct that carries a ripple over long distances without scattering. The sight is so gentle that many eyes might miss it, yet once seen it cannot be forgotten. It shows that the glow listens to breath from below, as well as to currents from above, and that the meeting of those breaths can write graceful geometry. There are also columns of rare color. Blue tinges sometimes line the bases of curtains when molecular ions emit in bands invisible to dark-adapted rods but recorded by cameras. The result in person is subtle, a cool edge to the warmer green above, like evening resting against lake water. In strong displays, violet can crown the tops of rays where nitrogen sings more loudly. Each hint of unusual hue reminds the patient viewer that chemistry multiplies the palette beyond the familiar, and that the upper air keeps a drawer of pigments for nights that deserve them. A puzzle in inverse appears as moving darkness. Within bright sheets, narrow lanes open that seem to erase light as they pass. They travel like slow fish in a clear river, sinuous and quiet. Instruments show that these lanes host downward currents that discourage electrons from entering. The darkness is not the absence of process, it is process with the sign flipped. Watchers find the effect restful for reasons that go beyond physics. Darkness moving through light takes attention by the hand and slows it, inviting a gaze that does not chase brightness, but follows shadow in a careful walk. Near noon, where open magnetic field lines touch the atmosphere, a special kind of aurora appears that belongs to the region where outer space leans close. The light there can be green or red or mixed, but the way it drifts carries a different gait. It sits under the entry door where particles from the solar wind can take a shortcut into the system. The display is commonly faint and requires dark winters to reveal itself. Yet its signature is unmistakable to those who know how to look. The pole seems to whisper that it is not simply a recipient of storms from the night side. It has a face that greets the wind and answers politely. There are also moments when the lower border of a curtain becomes a picket line of vertical lines that flash with delightful regularity, but without any companion ribbon above. These pickets can stand under an ordinary arc, marking small-scale channels of activity that align with magnetic direction. They feel like the sky practicing a gentle percussion exercise. The spacing can be so uniform that one could imagine counting beats with the pulse at a wrist. The experience is calming precisely because the pattern promises a stability that the mind trusts. A peculiar class of slow, luminous clouds sometimes shares the sky with the thinner heights of aurora. At the edge of space, where dust and ice assemble in summertime at high latitudes, bright filaments form that shine long after sunset. On rare nights, the green glow can paint above them while their silver threads weave below. The layers remain distinct even as they speak across the gap. The visual poem doubles in depth. The pairing is fortunate for the viewer who catches it. A high note sits above a whisper, and the ear of the eye blends them into a single assurance. Oddities do more than entertain. They correct assumptions. They show that light can arise from friction without the common electron rain, that bridges can cross the pole when topology decides to fold, that waves from the lower atmosphere can sculpt a celestial grid, that protons can write in softness where electrons would scratch with a fine nib, that darkness itself can be an active player. Each revision is gentle. None cancels the comfort that draws people to frozen riverbanks and quiet hillsides. Instead, the revisions deepen it by showing how many routes lead to calm. Names and categories arrive because minds love draws, but the sky resists being filed too tightly. A ribbon tonight may be broader tomorrow. A fence that flashed bright on one coast may barely show on another. A bridge through the cap may split and rejoin like a thoughtful pedestrian choosing streets. Variability carries reassurance of its own. It means the system is alive. It means that persistence does not require repetition. The watching body recognizes that kind of life and settles into a pace fitted to it. Every oddity carries a lesson in scale. The ribbon occupies a track only a few hundred kilometers wide within a planet-sized engine. The proton glow covers regions larger than countries in response to subtle changes at a boundary millions of kilometers from the Sunday. The comb-like dunes march in orderly ranks because of a wave that can travel half a continent inside thin air, invisible to any daytime glance. The mind that contemplates these proportions relaxes into perspective. Worries shrink against distances measured in field lines and ducts and particle lifetimes. The sky keeps more curiosities in reserve. Some are likely to be catalogued soon as instruments keep better watch. Others will probably remain rare enough to be lifelong stories for those who saw them once. The value of these guests is not only in the graphs they inspire, it is in the texture they add to the calm. They prove that serenity is not sameness. It is variety arranged with grace. It is a collection of distinct processes that all decide, for their brief time in view, to move with courtesy. A night that features a ribbon of mauve, a bar across the crown, a set of gentle dunes, and a line of dignified red would be a feast. More often, a single oddity shares the sky with the known drapery. That one extra note changes the whole chord. A person standing under it feels that the world has learned a new adjective for quiet. Cameras click more slowly. Voices drop without effort. A new hallway opens in the mansion of the Aurora, and those who walk it come back changed without knowing exactly how. The change is the point. It is the mark that subtle differences leave when they carry calm inside them. Machines lean into night with a patience that rivals glaciers. They listen for signals the body cannot sense and translate them into forms the mind can hold. In a quiet hut painted with frost, a photometer counts single photons as if keeping the pulse of an unseen animal. Each detection becomes a tick in a long ledger, and the ledger learns to speak. When the green line rises with unhurried steadiness, the ledger says that electrons are arriving with modest energy. When red climbs while green rests, the ledger says that altitude has shifted and that oxygen is taking its time to glow. The machine does not dream, yet its numbers condense into a story that a watcher can read like weather on an old farmer's face. Instruments that hear radio, rather than light, play a different role in the choir. VLF receivers stretch long wires across snow and listen for the chorus that sings far above air. Whistler mode waves drift through the magnetosphere like flocks of birds, and those receivers catch their faint pattern. A faint hiss becomes a signature of electrons gaining and losing energy in locked conversation with the waves. At higher frequencies, riometers watch the sky grow less transparent to cosmic radio noise when precipitation increases. A downward sag in the received power marks the arrival of particles both gentle and fierce. The sky becomes a fabric that thickens and thins, and the tool records each thread. Beneath many auroras, induction coils and fluxgate magnetometers stand guard and feel the tug-of-field aligned currents. They do not see color. They feel momentum unload from the magnetotail into the ionosphere. A sudden jump announces onset. A ringing at a discrete period announces a field line resonance singing in its preferred tone. Distributed across continents, these instruments link like a necklace around the pole. Their combined output is a map of invisible rivers. The map has no glamour at first glance. Then one learns that power grids and pipelines listen to the same currents for self-defense. Suddenly the map looks like a portrait of a living shield. Vertical profiles arrive from ionosondes that send a chirped radio pulse upward and wait for echoes from charged layers. The return time tells altitude. The curve of frequency against height reveals density and structure. During active nights, the E region hardens, the F region swells, and stratification appears that looks like layered sandstone in the data. Aircraft that rely on radio find their routes altered by these changes, and the ionoson provides the quiet reason beneath operational decisions. A single plot, traced silently in a warm room, is the hinge for choices made in cold air. Tools also turn light into maps, with an intimacy that photographs alone cannot achieve. Tomography gathers simultaneous images from lenses spread across valleys and islands. An inversion algorithm then rebuilds the volume emission rate as a three-dimensional sculpture that floats above mountains. In this sculpture, green gathers in sheets near 100 kilometers, red domes above like slowly melting glass, and nitrogen skirts the lower edge with blue threads. The sculpture rotates on a screen, and for a moment one feels that the curtain has allowed inspection from within. It is a rare privilege granted by geometry and code. Sounding rockets write in brief but blazing strokes. A team watches instruments and waits for a signature. The launch window opens, motors wake. The craft lifts into the very filament that a camera has been watching from a frozen field. For minutes, sensors taste the fields and particles directly. Spikes in parallel electric field appear on the plots like pine trees on a ridge. Electron energy spreads change as the rocket crosses boundaries thinner than a small-town street. The payload returns its data and falls into the sea or onto ice. The echo in the control room is a hush that feels like reverence. For a small time, the distance between theory and sky collapsed to zero. Spacecraft constellations solve problems that solitude cannot. One craft at a boundary senses magnetic shear. Another farther in detects a burst of energetic electrons. A third closer to the planet registers the arrival of an alphanic packet. On the ground, a camera notes a faint tremor in a thin arc. Later, analysts place the times in order, and the sequence reveals itself. Cause left a footprint that is longer than a continent, and instruments spread along the line of march collected it. 1,000 small clocks made one long sentence. In that sentence, distant forcing becomes local comfort. Data pipelines and archives have become as important as lenses. The night pours numbers into servers that never sleep. Timestamps carry precision sharper than a heartbeat. Coordinates tie each measurement to a thread in the planetary cloth. Quality flags mark moments when clouds strode across a lens or when a cable shook in wind. The raw stream is not music until it is cleaned and aligned. Then it becomes a score that anyone can play. Students on coasts who have never seen snow can pull kiograms from the archive and learn to recognize the signature of a westward traveling surge by eye. Curiosity no longer has a latitude. Testing ideas requires more than poetry and patience. It requires refusal to be fooled by beauty. Hypotheses are written in equations and then dressed in simulators that try to mimic the planet's behavior from the solar wind inward. The simulators are given the same inputs that the Earth received on a given night. If they produce the same timing of onset, the same migration of the oval, the same balance of green and red, confidence grows. If they do not, the failure is catalogued without drama. The feedback improves the code, and the next run gets closer. Science here feels like stonework, each strike of the chisel small and permanent. Uncertainty is handled with care rather than embarrassment. Instrument teams estimate calibration drift and background light, and the chance of misidentifying faint features. Modelers provide ensembles rather than single runs, and publish ranges rather than single numbers. Forecasts for power, utilities, and polar aviation include probabilities. No one pretends that a system this rich can be captured perfectly. The honesty itself becomes calming. It shows that clarity is pursued without arrogance. There is a subtler category of tool that touches the senses directly. Sonification maps field line resonances into audible frequencies. A low oscillation becomes a drone that thickens and thins. A chorus wave becomes a shimmer that creeps along the ear like wind on wire. Time-lapse compresses a long night into minutes and reveals patterns the eye cannot hold in real time. Color maps shift hues to accommodate the way cameras and eyes differ in sensitivity. The result is not a trick. It is translation. The experience moves from numbers to perception without losing fidelity. Another set of tools listens to places rather than to the sky itself. River gauges record small fluctuations in level, linked to induced currents. Tree rings in high latitudes whisper of ancient storms that altered growth through subtle changes in climate connected to solar variations. Ice cores trap nitrate spikes that may mark large episodes of particle precipitation. These indirect witnesses lengthen the timeline beyond the reach of cameras and rockets. They place modern nights inside centuries of memory. Fieldwork brings ethics into view. Instruments installed on northern lands often sit near communities with long traditions of watching the sky. Projects now include agreements that respect local knowledge and share data openly. Schools receive real-time feeds so that children can see the instruments their parents helped cite. Descriptions of the lights carry both scientific and cultural language without conflict. The union dignifies both sides. It teaches that understanding and reverence can share one tent. The circle closes each morning in rooms where analysts look pale under fluorescent light. They adjust clocks, subtract stars, mark clouds, correct bias, merge intervals, and then finally lift their heads to the plot that emerges. A thin arc brightened at 1:32, a front advanced at 1:37, a picket fence flashed at 1:41, a magnetic oscillation of 150 seconds began at 1:50 and faded at 2:05. The sequence lies on the screen like a soft path pressed into snow. Someone notes that it matches a theory. Someone else notes where it does not. Notes are saved. Another night waits. Tools that listen to the sky are not only instruments, they are habits of attention and standards of proof. They are agreements about calibration and about how to mark uncertainty. They are archives open to anyone who wishes to learn at midnight. They are launch crews in mittens and archivists at keyboards. They are citizens who step outside with phones and, by some care with settings, turn their images into measurements. Together they give the Aurora a second life, one in which its calm display becomes a source of knowledge instead of only a private solace. That knowledge flows back towards solace in a circle that needs little ceremony. A machine listens. The numbers arrange themselves. A person breathes a little more slowly and understands a fraction more of what the light was saying. Biology meets sky in the space between pupil and breath. A figure stands under faint green, and his eyes adjust as if the night were a dim room filled with moving curtains. Rod cells take command while cones step back. Sensitivity slides towards shorter wavelengths in the Purkinje shift, a quiet pivot that favors the very band where oxygen glows most confidently. The pigment in rods, so careful in its thrift, captures any available photon and passes the message along. A brightness that would vanish at noon becomes sufficient at midnight. The body is matching the Aurora's palette without any act of will. Dark adaptation has its own story. Photopigments replenish slowly, and in that slow replenishment the world returns in layers. First the horizon reveals its outline, then the low stars reappear. Finally, the faint edge of a distant arc resolves into a line that has been there for minutes, simply unacknowledged by impatient chemistry. The visual system is a long exposure camera when it wants to be. It lengthens integration times, pools signals across neighboring receptors, and allows noise to recede. What looks like patience in a watcher is partly patience in phototransduction itself. The sky grants this patience a worthy subject. Motion enters as a lullaby. The magnocellular pathway carries signals for movement and contrast along a fast route to cortical areas that notice drift and sway. It prefers low spatial frequency and slow, coherent shifts. Curtains deliver exactly that. Edges ripple across degrees of visual angle that feel like water stirring in a bay. The motion detectors fire at a rate that does not fatigue. There is no strobe to exhaust pursuit. Instead, there is a steady lateral glide that engages smooth eye movements. The same pursuit used to follow a gull over waves. Brain and sky agree on a speed. The agreement lowers the hum of vigilance. Color plays a softer part in this comfort. Cones still contribute near bright folds, adding a thread of hue to the largely monochrome gaze of rods. Green dominates but is occasionally edged with violet or capped with red. The mix stays inside the mesopic range where the brain blends signals from rods and cones, producing a palette that rarely shocks. Saturation remains moderate even during strong displays. The cortical machinery that guards against overload can rest. No region screams for attention while another goes silent. The eye receives a composition that uses the middle of the keyboard. Breath follows. The parasympathetic nervous system listens to slow, predictable stimuli and answers by loosening its grip on muscle tension and heart rate. A consistent cadence in the field of view models a pace that the chest copies. Sinus arrhythmia deepens, with heartbeats stretching on exhale as if the conduction system is nodding along. The vagus nerve, that long governor of calm, finds in the sky an example of how to proceed. The body's metrics do not need to be displayed on a watch to be felt. Shoulders drop, forehead slackens, hands warm slightly as vessels widen. The person in the field becomes the instrument the sky was always ready to tune. Sound, or its absence, contributes more than silence. The auditory cortex continues to predict events in the scene. Lightning trains the ear to await thunder. Fire trains the ear to await crackle. Auroras offer no acoustic sequel. The brain predicts and is not corrected. The prediction error fades to zero. That reduction in surprise is felt as relief. The mind is free to use bandwidth on sight alone. Even ambient noises, the crunch of snow, the distant salt grind of ice on a river, the small shush of a jacket, become accompaniments rather than alarms. Fractal statistics enter without declaration. The edges of curtains and the nested ripples along their base display spatial correlations over a wide range of scales. Natural scenes on Earth share this property. Leaves, surf, cloud edges, river deltas, wind-combed grass, and the aurora's folds all exhibit scale invariance within bounds. The visual cortex evolved inside such statistics and functions efficiently in their presence. Efficient coding means fewer spikes per bit of information, which is another way to say less internal noise for the same clarity. In this efficiency, the watcher feels refreshment. The brain is operating on home turf. Attention rebalances. Directed attention, the focus used to complete tasks, drains quickly and demands rest. Involuntary attention, the soft fascination that tracks gentle novelties without effort, does not exhaust. Auroras sit squarely in that second mode. They change enough to hold interest and remain predictable enough to require no vigilance. The mind enjoys a scene where engagement is free. The result is a restoration that psychologists have described in forests and along lakes. Here it arrives on a planetary ceiling. After an hour, the mind that arrived heavy leaves lighter because it was not asked to defend itself. Temperature assists. Cold air is an honest teacher of presence. It clears scents and quiets insects. It reduces moisture that would scatter city light. It presses watchers to move slowly and deliberately. The sting on exposed skin marks time in small doses, reminding the observer to attend to breath and posture. The physiology of thermoregulation becomes a partner that keeps the moment vivid. Warm clothing allows muscles to unclench without losing heat. The body reads comfort into the balance between protection and sensation. This is a cognitive ergonomics built of mittens and wool. Posture matters. Looking up opens the chest, the cervical spine lengthens, the weight of the head draws the scapulae downward and back. The diaphragm can move more fully because the rib cage is no longer hunched over a desk. The position itself invites calmer breathing. A ritual appears with no ritualist. Lift the gaze, relax the mouth, breathe with the light, wait. The alignment of bones and the alignment of field lines arrive at the same invitation. Memory participates by editing. The hippocampus writes down a sparse version of nights like this. It keeps the arc, the color, the cold, the shared silence if one is not alone. It discards most of the shivers and the brief clouds that wandered in and out. Later recall is filtered. The filter favors the calm and the wonder, and in so doing it prepares the body for the next time. Anticipation acquires a shape that has already been sanded smooth by recollection. Expectation aligns with the sky's actual pacing. There is less friction between what is hoped for and what appears. Circadian glands answer the light honorably. The glow is faint enough that it rarely interrupts melatonin production in all but the brightest arcs. For most displays, the hormone continues its nightly rise and carries sleepiness along. Contradictions soften. A person can be drowsy and enthralled at the same time, present and ready to sleep later without a fight. When strong arcs do flood the eye, they do so briefly. The endocrine system tolerates a short interlude of suppressed sleep signals without resentment. The morning arrives with rest intact because the interruption was narrow and kind. Perception of distance shifts. A curtain that seems close is actually 100 kilometers away, and a streamer that feels within reach is taller than a mountain. The brain compresses these absurdities and stores them as intimacy. The vault appears lower, the world larger, the self smaller in a caress rather than in a scold. That smallness is relief. It dislodges worries that had anchored themselves as if they were the center of things. Perspective rewrites priority lists without any stern lecture. Even the occasional camera becomes a tool for calm when used with respect. Setting a tripod, choosing a long exposure, stepping back, and letting the sensor collect what rods and cones cannot quite register at once is an exercise in restraint. The photographer becomes a student of delayed gratification. The image on the screen reveals colors more intense than naked sight, and details more defined than any retina could resolve. The goal shifts from possession to confirmation. The machine simply tells the eye that it did not imagine what it saw. Group dynamics carry their own physiology. People gathered on a ridge share soft cues, voices lower to match the quiet. Laughter thins into smiles that last longer than usual. A hand points and a dozen spines tilt as a unit. Oxytocin rises in settings where trust and calm are modeled by multiple bodies at once. The field becomes a low-dose social medicine, best taken with friends who know how not to speak too much. Even strangers fall into this mild trance of shared gaze. The result is a community tone that steadies the nervous system beyond what solitude might manage. Those who return to the same riverbank learn to pre-relax. Pavlov had bells, they have arcs. The road out of town establishes pace. The first star appears above the highway line and initiates a slow exhale. The path to the favored clearing rehearses past nights, with the brain's tendency to assemble scripts. By the time the green arrives, the body is already in the posture of receiving it. The sky meets readiness with generosity. Calm lands faster because the groundwork has been laid. Nothing miraculous is required to explain the comfort. The elements are cumulative and humane. Rod vision that prefers green, motion detectors that enjoy drift, breathing synced to gentle cadence, silence that removes foreboding, fractal edges that lower cortical load, attention that rests while engaged, cold that sharpens presence, posture that opens the thorax, memory that edits toward grace, hormones that forgive brief light, perspective that shrinks worry to size. community that slows speech and raises trust. All of these together make a person under Aurora feel like a tuning fork struck lightly and set near the pitch of the night. The sky is not a therapist, and yet it accomplishes a therapist's art. It offers a reliable space, asks for patience, mirrors the observer with broad and soft gestures, and leaves room for the mind to settle itself. The physics that delivers electrons to oxygen has no interest in human comfort. The physiology that turns photons into reassurance has no interest in plasma waves. Yet they meet in this field, under this dome, and share a middle. That middle is where relaxation lives. The person beneath it becomes briefly fluent in a language that both neurons and field lines can speak. Other worlds carry crowns the eye on Earth will never see directly, yet their stories widen the sense of calm. In the high latitudes of a giant planet made of storm and spun into bands, ovals of light encircle the poles like garlands that never set. There, magnetic fields far stronger than any compass could tolerate gather particles from a vast domain and pour them down along intersecting lines. The auroras above those clouds are permanent residents rather than occasional guests. If a person could stand on an impossible platform over that planet's pole and look into the night, the view would be a ring of soft blue and violet that hardly dims, a steady lantern fed by a system that drinks from space and from moons at once. One moon in particular keeps the crown bright. It is a little volcano farm that hurls sulfur and oxygen into its orbit, creating a torus of plasma that the giant planet sweeps with rotation. Magnetic lines tether the moon to the planet like a long leash. As the moon plows through the field, it drives currents that flow along those lines and light an oval footprint in the planet's own aurora. The path of that footprint circles the pole like a track half a continent wide, shifting with rotation and with the moon's changing position. Two other moons create their own footprints, smaller echoes that remind the viewer that satellites are not merely passengers, they are electrical partners. The idea that a modest moon can draw lines of light on a giant's crown is calming in its own right. It shows that scale does not erase conversation. The same giant hides a separate stage within its auroral circle where hydrogen sings. Emissions in the ultraviolet form an inner ring that means little to human rods and cones but a great deal to spectrometers. That ring brightens when particles from the sun arrive in force, and it brightens again when the planet's own magnetosphere squeezes inward or relaxes. The crown responds to two drivers at once, an inner engine powered by rapid rotation and moon-fed plasma, and an outer engine powered by the star's wind. The balance between them shifts without drama. The harmony is not a contest, it is a duet. Another ringed world carries an elegance of its own. Its magnetic field is simpler and more symmetrical. Its spins and fields align almost politely. Yet its auroras speak in similar wavelengths and gather in ovals that swell during harvested gusts of the solar wind. When a pressure pulse from the star reaches this realm, the pole answers with curtains that brighten and sometimes ripple in patterns that suggest waves trapped along long lines. The rings themselves remain dark at the wavelengths of aurora, but they provide a frame that deepens the tranquility of the whole. To imagine this quiet theatre is to feel a hush that fits a planet known for poise. Farther from the sun, other giants keep their stories more private. One carries a magnetic field tilted severely from its spin axis and shifted from center. Its auroral ovals twist into strange positions and wander as the planet turns. Another carries a magnetism that is more subtle and whose displays are faint, but still present when instruments have the patience to look. The geometry on these worlds is less kind to symmetry, but even that irregularity has a calm rhythm. The ovals rock and sway with predictable periods tied to rotation. The physics remains an old friend, rearranged. A small world without a global magnetic field tells a different tale. There, crustal patches of magnetized rock trap pockets of plasma. Auroras glow in scattered freckles rather than in rings, and the colors favor the green and blue of oxygen and hydrogen when protons from the solar wind convert to neutral atoms and dive through upper air. On days when the wind carries extra pressure, the freckles brighten in scattered regions reminiscent of old river deltas viewed from high above. The planet's thin atmosphere does not sing loudly, yet the quiet carries information. From orbit, emissions in ultraviolet trace where the wind has peeled at the air and where it failed. The overall impression is of resilience rather than fragility, a soft answer to a steady knock. A sister world wrapped in thick cloud lacks an internal magnetic field, yet it still glows. The solar wind flows around its conducting ionosphere and induces a magnetotail like a windsock pushed by invisible current. In that induced tail, particles can be accelerated and then returned to the night side where the upper atmosphere answers with faint light. The glow is intermittent and subtle. It proves that a planet does not need a permanent shield to produce luminous reply. Conduction and geometry can take the place of a built-in bar magnet, and the night will still learn to speak. Among icy moons, auroras reveal more than charged particles. A moon with a hidden ocean displays a rocking oval that shifts in position as the parent planet's magnetic field rotates. That shift betrays the presence of a conducting shell under ice, a global sea that completes circuits. The auroral wiggle becomes a liquid signature, a tracer of water beneath a casing of stone and frost. In another case, a moon carrying its own small magnetic field sculpts a tiny cavity within the giant's domain. It produces at its poles miniature auroras, as if it were a toy planet with a proper crown. The discovery delights in proportion to its scale and adds a new chapter where small and large exchange habits. Beyond the solar system, theory expects storms of light on planets clasped tight to their stars. Gas giants that orbit closer than Mercury orbits the Sun feel winds and fields far stronger than any in the local neighborhood. Their magnetospheres may be compressed to sizes smaller than the planets themselves. If close enough to fill a star's dayside with tides and currents, such worlds could drive currents through star and planet that raise emissions far brighter than anything seen at home. Telescopes already catch hints of radio signals that may be auroral in origin, a planetary heartbeat heard as static. When techniques sharpen enough to map those lights, relaxation may gain a cosmic scale. A planet lighting its star in gentle pulses is an image the mind keeps without need for drama. The principle that unites these places is modest. Where magnetic fields thread conducting gas, and where charged particles can be guided along those lines, energy prefers narrow paths. Those paths concentrate motion and lead it to regions where atoms and molecules can breathe it out as light. The rates, colors, and shapes depend on local chemistry, field strength, rotation, and supply. The feeling the thought produces is that of a universal grammar written with different accents. The grammar says that storms can become serenity at altitude, that quiet can be assembled from currents by the simple act of choosing direction. Relaxation, even as an idea, grows larger when one imagines these other scenes. On a giant world, the crown is permanent. The comfort would be continuous rather than episodic. On a ringed world, the glow would find its correct place within an architecture already tuned to elegance. On a small world without an intrinsic field, the scattered freckles would be a meditation on persistence in the absence of strong defenses. On a cloudy twin, the subtle glow would be a reminder that induced shields can suffice. On icy moons, slight wiggles would invite thoughts of oceans hidden but present. Each case is an essay in quiet, written by a different hand. None of this attention requires travel. The knowledge arrives through spectra taken above the atmosphere, through images in far-off bands, through radio whispers converted to plots. The mind completes the view. It builds bridges from numbers to picture, from picture to feeling. The picture that results is a family portrait. In that portrait, every member shares a tendency to organize energy into flow and to distribute it with grace. The family resemblance does not erase unique features. It draws them into harmony. The path forward looks generous. Instruments that see ultraviolet and infrared auroras will map ovals on fast-spinning giants with higher resolution. Radio arrays on Earth will search for the slow pulses of far planets as they write quiet arcs in magnetic fields 10 or 1,000 light-years away. Missions that dive through polar caps of giants will taste the currents that paint crowns and will measure the waves that accelerate electrons at the last step. Telescopes that dissect light from exoplanets will hunt for the chemical signatures of atmospheres shaped by steady particle rain. Each advance adds detail to a story that already soothes. It is the kind of growth that calms because it replaces ignorance with order. A person under a local sky can close eyes and travel by thought. A constant ring above a banded world, a ripple over rings and night, a shifting oval above a tilted field, a freckled glow where crustal magnets sleep, a whisper over clouds too thick for eyes, a miniature crown over an icy shell that hides a sea, a planet near a star, humming softly in radio. The scenes differ in outline and share one message. Magnetic architecture tempers chaos. Chemistry accepts energy with dignity. Space offers paths for motion to become light without roughness. The message is a comfort that does not depend on latitude. Forecast begins far from frost, where a star turns and lets slip patterns that drift toward a small blue world. A dark coronal hole opens and points a stream like a garden hose that will sweep past Earth days later. A flare lifts a bright knot of plasma that swells into a traveling cloud. Telescopes study the sun's face and limbs, measure magnetic loops that rise and collapse, and estimate where the streams will aim. Models take those images and push virtual parcels across interplanetary space. They ask how fast the wind will blow, how dense it will be, and which way its embedded field will tilt when it arrives. The answers are never perfect. They are good enough to prepare lanterns and cameras and to warn quiet towns that a green arch may visit. Hours from Earth, instruments watch the oncoming flow from a front row seat. They count protons, weigh the speed of the wind, and read the orientation of magnetic fields carried in it. When the field points south, it will splice more easily into our own and deliver energy with kindness or with insistence. When the field points north, entry will be stingy and the sky will remain dark. The numbers arrive in real time. Forecasters watch the plots lean one way or the other and send messages down the line. There is often half an hour of lead time, sometimes more, sometimes less. It is enough to dress, to drive, to find a hill away from lamps, and to let pupils widen. Closer to the ground, magnetic indices translate restless currents into compact summaries. One index listens to mid-latitude magnetometers and reports the general level of disturbance on a scale that fits in a single digit. Another listens to high-latitude stations and tracks the strength of the westward and eastward flow around the polar regions. A third tells how the ring of trapped particles that circles Earth has grown and what pressure it exerts on the main field. None of these numbers tells the eye exactly what it will see. Together they suggest the breadth of the oval, the likelihood of sudden onsets, and the areas where faint arcs might gather at the horizon. People learn to read these indices the way sailors read wind feathers on water. It is a language taught by error and memory. Forecasts separate into two kinds. Days ahead, models take images of the sun and feed them into simplified winds that run outward along spirals. They are rudimentary, but they capture the broad brush. A coronal hole rotating into view hints at a stream that will raise activity in 3 or 4 days. A halo of expanding light around a flare hints at an ejection that may carry its own field and arrive within 2. The timing shifts as the disturbance moves. The orientation of the field inside the cloud is unknowable until it nears Earth. The forecast therefore keeps its verbs soft. It says likely rather than certain. It says window rather than appointment. Minutes to hours ahead, nowcasts take what the upstream monitors report and project it forward. If the solar wind suddenly doubles its pressure, the magnetosphere will compress and the oval will widen. If the field flips south and holds, energy will load and a pulse will follow. Algorithms trained on past nights convert these inputs into odds that a given longitude will host a surge. A camera network receives a polite prompt. A pilot guiding a polar route considers an alternate path. A family in a small town gathers coats and a tripod because the map on a phone has changed from grey to green. Weather for the upper air uses the same arts as weather near the ground. Data assimilation blends observation and model in a dance that corrects both. Ensembles run many variations of the same situation to estimate how much the answer depends on small changes at the start. Probabilities emerge rather than single lines. On a given evening, the guidance might say that there is a 30% chance of arcs at mid-latitudes in the hours near midnight, with a 10% chance of a stronger surge that might reach farther south. It might add that if the wind speed exceeds a certain value, and the field remains tipped south for more than 20 minutes, that 10 may become 40. The watcher learns to accept conditional promise. The sky rewards this philosophy. Citizen networks convert probability into presence. When cameras send up their first frames of a faint arch rising on a northern coast, the map changes color inland. When witnesses confirm that green has broken above a tree line, an alert pings the next valley. The lattice of reports shrinks uncertainty faster than any model can on its own. People on back roads become part of the instrument. Their images carry time and place. Their eyes edit out clouds and reflections and deliver what matters. The effect is not purely practical. It also builds a sense of common purpose that makes late drives along empty highways feel less solitary and more like a migration. Forecasts respect geography. Magnetic poles sit far from the geographic ones, and the oval follows them. A town with a high latitude but far from the magnetic pole may see fewer displays than a town at similar distance that lies under favorable longitudes. The tilt of Earth relative to the Sun shifts the region of darkness into or away from the oval. Equinox seasons often grant longer nights that overlap with times when coupling between solar wind and field is efficient. Local weather has the last word. Clouds erase accuracy. Forecasts learn to include course guidance on cloud cover. The combination becomes a ritual of choice. If the field is south, and the wind is brisk and the clouds are thin, one goes. Power companies and satellite operators read the same charts with different hearts. They ask about induced currents, about drag on low orbits, about radiation belts growing heavier. The alerts they receive translate poetry into risk. Elevated but not severe, severe but brief, quiet returning by dawn. These phrases carry decisions. They lead to actions hidden from ridgelines and beaches, but essential to well-being. The grid and the sky thus share a calendar. A plan to inspect a long transmission line might be moved to a calmer day. A satellite might be rotated to reduce cross-section. The calm that auroras deliver to eyes is mirrored by calm in control rooms when forecasts give fair warning. Forecasts include caution for misinformation. Images spread quickly, and sometimes the promise of green outpaces the probabilities. Agencies and observatories frame their notes with context. They show what is likely at high latitudes and what is merely possible at lower ones. They remind everyone that the orientation of the interplanetary field is decisive and that it can change in minutes. They teach terms without scolding. Once learned, the language protects against disappointment. A person who knows how to look at a plot of field orientation and speed will understand why a night stayed quiet and will return another night without resentment. On the personal scale, small habits increase joy. Dark sites are scouted in daylight. A thermos and spare batteries are standard. A camera is set to record time-lapse, while one chooses to watch with eyes unhurried. The forecast serves as an invitation rather than a guarantee. When light rises, it feels like a gift. When it does not, stars still pay their rent. The practice becomes a meditative discipline sustained by gentle probability rather than by demand. Cycles add slow music to planning. The sun's activity swells and recedes over years. The count of spots on its face roughly predicts how often the wind will carry structure and how likely strong storms will be. In busy years, patience is rewarded frequently. In quiet years, one leans more on models of coronal holes that deliver reliable streams. Both kinds of year have their charm. Busy nights invite crowds and shared awe. Quiet nights reward the few who keep watch and discover that faint arcs are their own kind of balm. The future of forecasting looks generous. More small satellites will fill the region upstream with extra eyes. Radar networks will cover oceans where gaps remain. Cameras with faster sensors will measure the quick flutter of thin rays and help decode the small-scale electric fields that clues depend on. Models will couple the deep atmosphere to space with higher skill so that tides and planetary waves can be included in timing. Machine learning systems will translate strange combinations of inputs into guidance that is both humble and useful. The result will never be certainty. It will be enough. The last ingredient is kindness in communication. Alerts that promise too much erode trust. Alerts that speak plainly about uncertainty invite companions rather than consumers. A forecast that says prepare for a chance of beauty And remember, the cold yields more satisfaction than one that shouts. The tone matters because it matches the subject. The lights ask for patience. The guidance should too. When the message arrives that the field has turned south and the wind is fast and the currents are starting to rise, some leave houses and some simply step onto porches. The lights at the edge of town dim where they can. Eyes adapt, arcs appear or do not. The art of forecasting ends at that border between numbers and lungs. On good nights, the sky answers with a line of green and then with a surge. On quiet nights, it answers with stars and the feeling that the waiting itself was already a kind of peace. Either way, the pact holds. The star sends, the instruments listen, the models whisper, the maps glow, the people gather, and the night becomes a classroom for breathing. Night turns the world into a single room where attention learns its own posture. Under a pale arch, the mind that usually accelerates begins to idle at a lower pitch. It discovers that slowness can carry information, that quiet can be articulate. The lesson is not delivered in sentences. It is shaped in light that moves with composure and in electricity that prefers slender paths to broad assaults. The student is a body with open eyes. The teacher is a vault of thin air, translating distant power into softness. The curriculum is patience, proportion, and care. The first teaching is how to measure without haste. A curtain does not reveal itself in a glance. It develops through minute-long gestures that require breathing to match them. This obliges the watcher to let go of the twitching clock inside the chest. In the letting go, a different measure of value appears. Worth is not in speed or quantity, but in the fidelity of attention paid to a single changing shape. This transfer from hurry to regard is felt in muscle and pulse. The body memorizes it as a usable stance for daylight. The second teaching concerns scale. High above a lake, atoms absorb a few kilo electron volts from descending electrons, radiate at specific colors, and compose arcs that reach from horizon to horizon. The energy per patch of sky is small. The total balance across the hemisphere is immense. The lesson follows naturally. A modest amount distributed widely can make a calm that feels endless. In human terms, small courtesies extended often become climate rather than weather. The lights preach this quietly by existing at all. A third instruction arrives in the geometry of lines. Motion that could explode into confusion is channeled by invisible structure into forms that hold their edges. That structure does not devalue freedom. It shapes it so the result is legible. A life without boundaries becomes noise. A life with chosen rails becomes music. The sky demonstrates a disciplined grace that does not announce itself as constraint. It arrives as beauty that would collapse without guidance. The observer absorbs the idea that alignment can be liberating. There is also a class in humility. The eyes do not command the show, they only receive it. Instruments can anticipate possibilities, but no one can decree a surge. Acceptance grows where demand would normally stand. The acceptance is not resignation. It is willingness to be surprised without complaint. The calm that follows takes root in this posture. It is a trust that something generous can arrive without being forced, that waiting with respect is a kind of participation. Another chapter concerns translation. Energy leaves a star in charged streams and magnetic fields, crosses a silent gulf, meets a planet's shield, and arrives in the atmosphere as color that human tissue can register and enjoy. Throughout this path, everything is conserved, yet the meaning changes. What could harm becomes light to look at. The change of meaning is not mystical, it is the result of mediation by structure. The implication is practical. When structures are built with care, difficult forces can be transformed into forms that enrich rather than destroy. The night gives a model for stewardship that does not deny power, but arranges it. The education includes generosity toward error. A forecast can miss. A camera can fail to trigger. Clouds can drift in just as a front rises. None of it negates the worth of being present. The arc that does not arrive leaves stars to study and a slower walk back to the car. The person who expected spectacle receives instead the training of disappointment that does not curdle. The next invitation is accepted with the same readiness. Over time, the emotional weather evens out. Peaks soften, troughs soften, and the long average climbs. Light on snow teaches clarity without glare. Landscapes under green have no hard edges. Shadows do not shout. The image in memory resolves into shades that please the eye's preference for midtones. The brain stores the event as an atmosphere rather than as a set of objects. This favors recollection that heals. Memory returns with the tone intact and without the hooks that snag. The mind learns how to keep its own archive without defensive thorns. There is also instruction in companionship. Bodies standing in cold share breath patterns, hand gestures, and wordless acknowledgements that knit strangers into brief communities. A pointing arm is enough to coordinate a dozen gazes. The shared silence is not empty. It is full of aligned attention. This is social coherence without noise. The nervous system takes note that such coherence is possible and not costly. Daytime inherits the knowledge that groups can focus without raising their voices. Time under green reveals the value of thresholds. A faint arc hovers below visibility until the eyes adapt, and then suddenly it appears as if conjured. Nothing in the sky changed. The threshold of detection changed. Much of life hides under similar thresholds. The lesson is to grant conditions that allow signals to cross into awareness. Darkness, in this case, is not absence. It is a necessary partner in seeing. In the same vein, stillness is not idleness. It is a condition that brings buried patterns above the line, where they can be noticed with kindness. The lights teach conservation of attention. There is no benefit in scanning the entire vault in panic. A steady survey with periodic returns to one corner yields more joy. Concentration that wanders gently is superior to concentration that fractures. The watcher becomes curator of his own gaze and learns not to auction it to every flicker. This carries back into rooms filled with screens. The aurora becomes a tutor in selective focus. A deeper lesson hides in the persistence of quiet forms amid larger upheavals. A thin arc can hold while a surge roars elsewhere on the oval. The mind learns to keep a calm center while acknowledging motion at the edges. Anxiety has always offered to paint the entire field with one color. The sky demonstrates a counterproposal. Complex systems allow islands of stillness. The correct response is to locate one and stand within it while remaining aware of the rest. This is a habit worth rehearsing. Care for place grows naturally from such nights. The air that carries light must remain clean. The horizons free of unnecessary glare. The power lines and pipelines protected from storms by good engineering, informed by good forecasts. Stewardship becomes personal rather than abstract. The feeling of being sheltered under a working shield translates into gratitude that seeks maintenance. The planet is not a backdrop, it is a collaborator. The desire to treat it with courtesy follows without sermon. The classroom of the vault delivers its most intimate credit in breath. The chest copies the motion overhead. Inhale on the rising fold, exhale on the settling veil. Repeat without effort. This entrainment writes calm into muscle memory. The next time urgency threatens to tighten everything, a practiced inhale remembers the arc. A practiced exhale remembers the drift. No mantra is needed. The green provided one. At some point, the lesson turns to silence itself. The absence of crackle where brightness blooms is not emptiness. It is an affirmation that not all power requires sound to be real. Silence can be authority, not lack. A person who learns that at midnight carries it into conversations that could have been arguments. Voice can drop, meaning can grow. The aurora becomes grammar for restraint. Finally, the vault suggests a way to hold wonder without letting it rot into possession. Cameras can record, but the point is not to hoard images. The point is to be altered. Alteration has no file size. It shows in the slower blink, the better posture, the kinder sentences the next day. The education is practical. It teaches methods for being here with grace. When sunrise arrives, the material of the course remains. It lives in blood chemistry that learned to settle, in neck muscles that learned to lengthen, in a mind that accepted scale and relinquished insistence. The lights will not be there every night. The learning will. It does not require repetition to stay true. It requires the occasional reminder that a storm can choose to be delicate once it meets a field that guides it. That reminder can be a memory, a photograph, a winter breath that smells like river ice, a star seen through thin cloud. Any of these will do. The quiet education of night survives transfer into day. Night folds its tools and sets them neatly on the horizon. The vault returns to its deep ink, and the world under it feels like a cup just rinsed. In the mind of the watcher, slow light continues even without the sky to feed it. Breathing keeps the cadence it borrowed. Shoulders remember the lower position. Steps remember where the snow squeaked. Nothing spectacular announces the end. The river of air closes its green door and leaves a soft print where a hand once rested. In this afterglow, distance feels kinder. The space between heartbeat and thought widens enough to pass a quiet word. The day ahead waits on its heels. It will bring chores and voices and the familiar crossing of hours. The newly learned pace does not reject any of it. It simply chooses an angle of approach. Tasks are stones to be placed in a path, not walls to be climbed. Sentences are threads to be tied, not knots to be fought. People are weather, and weather can be read. Memory holds detail, like a pocket lamp. There was a ray that thinned to a strand. There was a line of faint pickets near a stand of birch. There was one star that blinked through a veil and reminded eyes that distance is generous. These small items carry more warmth than any forecast could promise. They are enough to last until frost returns and the oval chooses to breathe again. He steps toward shelter. Doors welcome with the soft sound only doors make at late hours. The room smells of wool and steam. Windows reflect a face, newly simple. Outside, the cold finishes its sentence over fields that have learned how to listen. The lesson is not loud. It is steady. Move gently. Align with what is already aligned. Let the strong forces you cannot touch become light in your keeping. Sleep arrives as if it had always been waiting, which of course it was. End of script. Sweet dreams.